something like this, okay? And the presentation is under this foldery thing, and even more important is the I2K PDF, okay? So you can follow the presentation on your screen, and you can then follow on your screen this PDF, which contains everything we will go through with you today, okay? Right, so without further ado, good morning again. In the I2K conference, the OMERO workshop. My name is Peter. You can see my full name in the participants list of this Zoom. It's hard to pronounce and not so interesting. And this is my colleague Jean-Marie Bourrel. Okay, we are members of the OME team. So in the outline, I will tell you what OME is. OME stands for the Open Microscopy Environment. Then I will go ahead to talk about OMERO and give you some workshop overview. Okay. So OME is something like a hub in the wheel, a central piece of parts which were originally not meant to talk to each other in the microscopy world, of course. I mean, this would be the acquisition software, which produces many proprietary file formats. We support more than 150 of them. Then how to connect it with visualization, data management, and tagging, how to enable the quantitative data analysis on those image data, and make a sensible connection with the process data, let's say the results of analysis and other metadata. In order to achieve this goal, the OME, which is basically a team of people who produce an open source free software, is producing a software package. One of the software packages called OMERO. OMERO is a data management system which is constructed as server with clients. Now the clients might sound a little bit awesome, so let's leave it aside. Let's start with the server. So server, you know, this is some complex or powerful machine which is not run by you typically and is not accessible by you. It's somewhere else physically, and it will be probably run by your IT. There will be a specific room. There will be a forest of wire. It's locked for you. It's fine. But obviously, with each thing you want to use, you have to access it somehow. So the access to the server is facilitated from your local machine, your desktop or laptop, which you are sitting in front of right now. And it has a connection to internet, in OMERO's case, definitely. And on your laptop or desktop, there is running an application which is connecting to that server, which is capable of connecting to that server. And the application, the local application, that's what we call client. That's all what there is to it. So I will use the word client in a phase that you understood what I'm saying. And let's just introduce the particularity. So this is again a redraw of the previous cartoon. All our image data are stored on the server. Okay, we support more than 150 different file formats using a Java library called bioformats. Maybe you have heard about this as well. It includes the variety of imaging modalities, such as biological, medical. You can also upload your holiday photos, there's no problem. Height content screening data and whole slide imaging formats as well. These images are connected with metadata using the relational database, which is the OMERO server is using, And yeah, if you think about metadata and annotations, also think about ROIs and segmentations. These are for us also metadata. Okay. You can search within the OMERO server using search, and we have also some framework for storing of analysis results, which would typically come from, let's say, third-party tools such as Fiji and similar, which can produce typically a large table of with rows and columns, and you would like to have that stored to close to the images and in relation to them, which were originally being analyzed like that. So this is just an example of high content screening data. We will go through that in the workshop, that's fine. This is whole slide imaging data, very large images, typically some HN staining sections. This is obviously not microscopy, but CT scan of the whole brain. And it is in the popular medical imaging format called DICOM. So we support that as well. Now, the next topic is talking about more or less how do you access the data which are in OMERO. So OMERO is not some dead end storage. It is enabling live interactions with the images which the server stores. And this is facilitated by the OMERO API. API stands for Application Programming Interface, and you can imagine that as kind of hedgehog of plugs which are on top of the OMERO server, and you can simply come and connect your own software, such as if you have a script in Java or MATLAB, you don't have to somehow rewrite it in an OMERO language, but you can take this script and use this OMERO API to plug it into the OMERO and unleash the power of your script onto the images which are sitting in the server. This slide is basically reiterating what I just said. It doesn't look like that on the first look, but if you think about it, the integration with third-party software, which is highlighted here, you certainly know Fiji, I'm sure maybe Elastic, QPath, R, Napari coming up, MATLAB. So each of those softwares is ultimately written in some language, such as Fiji is written in Java. So you can already see the relation to the previous slide. If you have the OMERO API, then you can simply write a glue between a glue code, a piece of software between the, let's say, Fiji, the third-party software, and OMERO, and integrate those two. So there will be examples about that as well. Our main client, remember the word from the beginning, we have two clients, graphical user interface clients, the OMERO.insight and OMERO Web, pardon me. And the main effort of the team is going now into the development of OMERO Web. Now, OMERO Web is, as the name says, web-based client, so it runs in your browser, and it's written in such a way that you have an environment of plugins for OMERO Web, so you can easily extend it. And you can open such plugins by clicking on, let's say, an object in OMERO. Why don't I say image? Well, because it can be also dataset or project, simply a container of images or some such. And then open this image or dataset in a variety of viewers. So we have two viewers. One, our main viewer is called I2K. OMERO.figure, you will see during the workshop extensively a 3D viewer as well. which is integrated. Now, this is a little bit of a different topic. The IDR stands for Image Data Resource. This is a service which the OME team runs for the scientists of the world. Its purpose is to store, serve as a reference base and a reanalysis service for the scientists in the imaging world. The images there are being submitted to the OME team, or better said, IDR team, which is a sub-part of the OME team, and it functions as a publisher. So if the images are connected to a publication in a scientific journal, then the publisher called IDR will simply put the images into the IDR database, which is running on top of OMERO. So this is one of the production examples of OMERO, among, of course, thousands of others. The content of this workshop is to be gleaned from OMERO guides. Okay, so I just pinged you the link to, Jean-Marie pinged you the link in to the materials here, but ultimately, if you really go through that PDF, it will always point you to some part of these OMERO guides, okay? And this is to emphasize, even if you kind of lose the context of this workshop later, or you meet somebody who don't care about the workshop, of course, then the OMERO guide is to be used on its own and can be navigated and searched, as you will see plentifully during the workshop. If you intend to set up OMERO in your home institution, then you might be interested in this slide. What you would like to do is to attract users, of course, to use it, and then how to introduce people on a daily basis to OMERO. And for that, you have those 3 links here. They all are pointing to OMERO guides. And such as you can click on one, and this is your walkthrough for facility managers. Okay, so typically such setups work like that. Unlike the IDR I just mentioned, which is run by the OME team, the OMERO instances are run by the particular institutions. So a typical OMERO instance will be per institute, and the institute will take the free software which we are shipping called OMERO and installs it on their own hardware and runs it on their own. Okay. What do we do in today's workshop? The setup for this one is fairly simple. We have here the light blue line, which again denotes internet. We have 2 lines like that, so there are 3 places, so to say. The top left is your own desktop. That's the thing you are sitting in front of now. Then we have the OMERO server. The OMERO server in our case is located in Dundee, United Kingdom. That's the city I'm sitting in, but I'm not sitting with the server either. I'm sitting in my flat, which is somewhere in Dundee. The University of Dundee campus is down the hill there, and there is somewhere a building where the server which we are using is located. Its name is a workshop. That's just for our convenience, and all our images are stored on that server, so they have been pre-imported there. Very good. And this is something I come to in a second. So on your desktop, there are obviously some web browsers. I'm sure that you have some. Firefox and Chrome are listed because they are leaders of the market, but it will run fine on Safari or even Edge as well. Then possibly you have installed Fiji with the Fiji plugin for OMERO. and you can use that to connect to the server as well. I will show a little bit of an import using OMERO.insight. That's the other client. Now, that is probably clear. What is here? This is another remote environment which we prepared for you. With the usage of a free service called MyBinder. You can do that as well. You can simply go and do what we tell you later in the workshop and repeat the spin up of a full environment for yourself, where you would have, let's say, Cell Profiler running in that environment, and then easily connect the Cell Profiler to the OMERO server of your choosing, such as this. The environment also contains something called Jupyter Notebooks. If you happen to know that, this is easy to use web-based environment where you can simply study pieces of code and execute them in a very user-friendly way. The OME is a grant-funded organization, and we have these funders to thank to. Mainly, the money comes from BSRC and Wellcome Trust. Okay, so let's start with the workshop. I think
maybe from a practical standpoint, Peter, we'll
yes.
take 15 minutes break just to get people a chance to move their legs. So
Yes.
one at the 10:15 our time, so so that would be 11:15 for Europe. So whatever, roughly in 50 minutes, we'll take a 15 minutes break, and another one after that around 11:45 our time. So we basically do an hour and 15 minutes, 15-minute break, an hour and 15 minutes, 15-minute break, and a last hour of the workshop.
Very good. Thank you. So this is for the time planning. We will cover in the first 1 hour and 15 minutes. We will cover topics which are highlighted in the first part of your walkthrough. Let me navigate again to the walkthrough, which you are hopefully also studying in front of yourself. This is here, and the topics we will do in the first part are covering something like this: import and the OMERO core concepts. Okay. So I will tell you something about import now. We have two ways how to import into OMERO. By import, I mean you have to upload somehow the images into OMERO so that OMERO registers them and they are contained in the server. They don't come there by magic. So our main way here, which we will explore, is using a desktop Java client called OMERO.insight. Okay, there is yet another way called command line interface. I'm not going to show you that, but just bear in mind you can do that as well. We can go into details later. So in order to have OMERO.insight, you simply go to the OMERO guides, which is to the link which is highlighted here. And here is everything you need to know about how to install OMERO.insight. We didn't tell you to do that. It's very easy, but you, for example, have to have Java installed on your machine. Yeah, just for the sake of sparing time, I will just quickly show how that goes. So I have OMERO.insight downloaded and installed on my Mac. This is now everything running on my Mac. You can see the icon popping up here. I have here a spanner where I have to choose the right server, such as this. The server address is workshop.openmicroscopy.org. Maybe we can start pinging you.
I've put that, but the first time you come, those list of address is what Peter have already, the server Peter have connected to. If you come up the first time, you won't have anything in that list. That's need to be clarified.
Yeah. So if I would have downloaded a fresh insight in a fresh environment, just like you do, I would probably have just localhost there. Okay, so then in that case, you have to click on plus and type in the server address here. I would be typing something like workshop.openmicroscopy.org, etc. And then it would pop up in the list such as this, and then I select it and say apply. So if I connect, then I connect to the server demo. As I say, it's just about understanding what's going on here. The import icon is the fifth from the left. It's the upward facing arrow, and I just click on that, and a new window opens, which we call importer, and I will simply select. I will simply select two images from the left-hand side. The left-hand side is browsing my local Mac here, and I can put them into the import queue. Now it says I can put them into data sets, new data sets, and projects or existing ones. Data sets and projects are simply containers and two levels of hierarchy of containers into which you can import into OMERO. You can create a new data set to import to just like this, but you can also say nothing. And if you do so, then OMERO.insight will simply take this, create a new data set for you and take its name from the name of the folder in the local hierarchy. In my case, this will be the name desktop. Okay, so if I pop it in the queue, you can already see OMERO.insight is highlighting that the images will be put into the dataset called desktop, and I press import. There will be two progress bar in import. The first is the upload. This is simply copying of the image from my local Mac to the server machine. And the second bar is processing of metadata, creating thumbnails, and simply kind of Omeroizing the thing. But by the way, by Omeroizing, I do not mean that the original file format will be somehow changed, or that we will write some OMERO format. That's not true. The original file, in this case PNG, will stay a PNG inside the OMERO server as well, and will be stored there safely, and you can always get back the PNG or whatever CZI format or SVS format which you imported. Okay. Now, if I go after a successful import, I go and refresh this tree. The new data set called desktop is there, and I have the two simple screenshots imported. But you can now make this jump with the workshop.openmicroscopy.org, or simply click on the link which is in the Zoom chat, and you will end up here. Okay, so do you see something like this? Because I would like you to be able to work with that. So if you can be so kind, give me some hint or
Yes.
give me some hint. Yeah,
Yes.
thank you.
Yeah,
Thank
yeah.
you. Great. So for yourself, I will just say, for first time, I will log in as user 50. Okay. Okay. And you can see that my name here is Irene Joliot-Curie, and I have my data here. But that was not the person who imported the data in OMERO.insight. The name of this person is funny. Is the first name is trainer1 and the second name is trainer1 as well. So how do I see the data which I have, which trainer1 has imported, me being now Irene Joliot-Curie? I will click on the top left. There is a lab1. This is a group which we all share together. It's a read annotate environment. I will go into that in a second. And that's how I navigate to data of other people. Okay, so I can go here and I can navigate to data of trainer1. You can do that with me now. Okay, be careful not to jump to lab 2 when you are driving with your mouse over to the right hand side. Just stay nicely level. Lab 1, even go a little bit higher. Lab 1, trainer 1, okay? So if I click on trainer 1 has the richest data. And I can see here the folder called desktop. That's what I imported, and here are already some interesting dataset details. You can trust me that this was me, because you can see the date is 02. This is the 2nd of 12. This is the December. Is obviously today, and it was 9:32 of the UK time. So the owner of this data set is trainer 1. This is not surprising, because we are looking at the portfolio of trainer 1. You can see it here on the top left. Okay, I'm still though Irene Joliot-Curie. Yeah? That's what I would like you to do as well. Look at the portfolio of trainer 1, and then you can see that the owner of the imported images is trainer 1. Okay, if you click on single images inside the data set, it's again trainer 1. There is no mystery about that, hopefully. Yeah. And now let's do something else. If I go back to my own portfolio, I'm Joliot Marie Curie, not Marie, but Irene Joliot Curie, pardon me. And I will now again imagine that I'm trainer 1 using another client called OMERO.insight, yes? And I will do another import, but this time I will not import for myself. I will import for a user called Irene Joliot-Curie, okay? This is user 50, as I remember. I click again on the arrow to pop the images to the queue. I'm now in the local environment in the desktop client called OMERO.insight again. I'm trainer 1 in that insight, and I'm importing with the intention to import for Joliot Marie Curie. Joliot, Irene Joliot-Curie, pardon me. So this will be under C here. Maybe it will be under J. Yes, it's under J because it's a name with a dash. And yes, it's there. Irene Joliot-Curie. Okay, so I'm important in a group lab 1 for Irene Joliot-Curie. I am trainer 1 here. I add it to the queue. Maybe I can go back and do it again. Something more interesting. I can create a new project, and the new project would be called trainer 1 for Joliot Curie. Okay, so that it's clear what is happening here. Trainer 1 is importing for Joliot Curie. Add and import. Okay. Again, the same process. That's not so interesting. But if I go to the web client, and in the web client I am Irene Joliot Curie, that's me, and I will refresh my tree. I can see a new project here called Trainer 1 for Joliot Curie. Hopefully this rings the bells for you. If I expand it, I have a data set there called desktop. We know why it's called desktop by now. I have 2 images in the data set. That's all great and swell. But the most important part here is that the images, as well as the dataset and the project, now belong to me. And me, he is here. This is what is in the top right, is Irene Joliot-Curie. So what you just saw is that although the action in Insight was fully done by trainer 1, the resulting imports are belonging to Irene Joliot-Curie. So we simply import it for somebody else here. Yeah. Hopefully that's clear. Now I will log out. Well, actually, I don't need to do that. I can navigate to trainer 1 again. No, I will log out. Sorry, I was confusing myself. I will log out and log in again. You don't have to do any of that. You can stay logged in. Okay, I will log in as trainer 1 into Omero Web, and we will go now. We are done with imports. Maybe just to mention that on the command line, in the command line interface, you can do more than that, which I just showed you in Insight. You can also do so-called in-place import. Okay, the in-place import is covered obviously in the OMERO guides. And if I very quickly go through this, the in-place import is allowing you, as this scheme um, shows, something, a method which will not duplicate the data volume as you are importing images into OMERO. So the classical import we just went through is simply copying from my PC or some, let's say, Samba shared drive, is copying first the image onto OMERO server. So there is a duplication of the necessary storage volume, because typically this might not be PC. This will be again some shared drive in your institution. So another server, and then the OMERO server will also be run by your institution. This is what we've done with OMERO.insight, and this is the only possible way with OMERO.insight. Nevertheless, if you use the command line interface, then you can do in-place import. And this means that you have to have access to the OMERO server physically, or rather via SSH. You can SSH into the machine of the OMERO server, and then you can run the in-place import. And the in-place import is not copying the image as highlighted here. Instead, it will just find the image on some storage place, which again will be some server, which you mount it on the OMERO server machine. And the import in this in-place case simply consists of creating that link between OMERO server and the place where that in-place place where this image is living, in a clever way. By creating in a clever way, it means that not only is there the link, and thus OMERO server knows where the image is. By the way, don't edit the image or anything after you've done such import, because otherwise OMERO would lose track of where the image is. But also on top of that link, OMERO does the import. This means it also again grabs the metadata and creates a thumbnail and puts it into the relational database here. So that you have exactly the same experience then later when you are using OMERO with the in-place imported images, just like you have when you imported them in a classical import. If you are a pure OMERO user, you didn't bother with import, somebody did it for you, you don't even recognize which image was imported in place and which image was imported in a classical way. Okay.
Yeah, the in-place import is quite important when images are big, but also to automate import for users, so that there are places where people acquire the data, and all the data that go in specific area are then automatically made, I would say, OMERO aware, and the link are created automatically, etc. So the user doesn't have to go through the client, pick and choose. He just connect, and then he see the data appearing as things goes. Basically, those jobs, you can have job running overnight to move data, to make the data OMERO aware. So I think that I think it's a bit more involved into the setup, but it's a, when you're running facility, it's a quite a it's probably a more suitable approach in some cases, especially with the now data like light sheet data, which are very big.
Very good, thanks. So this is what we wanted to show regarding the import. And now again the big switch. Don't get dizzy from that. I will slowly but surely be drowning in my tabs. I will close some. Pardon me for that. I am now back in OMERO Web. Are you with on the same footing with me, ladies and gentlemen? Uh, yeah, back in OMERO Web, I'm logged in as trainer one, you are logged in as user, whatever, and you have a nice scientific name here on the top right. Some of you will be, let's say, Charles Darwin or whatever. I was Irene Joliot-Curie a second ago, and you are browsing the data of yourself in this case is fine. You have here the same name as here, okay? And then let me go just through for what we have here. So these images, by the way, all imported in place, except for those which I just imported in front of you. They are of differing file formats. This is the DICOM, which I was showing in the presentation. Here we have some conventional microscopy images from in a delta vision format, and there are some deconvolution images together with them, which were also imported. Here are some whole slide imaging formats. In this case, it's SVS, and pathology images, really seriously big. This one has something like 100,000 by 50,000 pixels. Okay. And they are side by side with high content screening images, which are in a screen plate 12 format. So this is basically the 96 well plate, and you have an automatic microscope which will shoot an image in each well or more images in each well, and then it stores them in some formats like Flex or Operetta, and the bioformats are then able to import the whole beast with the superstructure containing the wells and images in them into OMERO, and that's how it looks like. Okay, so all these formats and very different file formats are side by side here. I will return to the conventional images. How is it possible? Well, again, the Java library called bioformats is reading those images on the fly. As I, for example, double click on it and it opens in a full viewer, then the bioformats is called, and the bioformats library is consisting out of readers, and the bioformats library will pick a appropriate reader to read the image I just clicked on. In this case, it would be a DV reader, and on the fly reads the original file, which is stored in the OMERO server, and displays it in the full viewer of OMERO, which would be here the OMERO.iviewer. We will see that in the second. And the same applies for the DICOM images I just showed you in the second. So again, if I double click, then the bioformats picks the right reader, etc., etc. In this manner, we really store the original data, and we don't have any intermediary format. And everything is done on the fly using bioformats as highlighted. On the left-hand side, I have the projects and datasets. The projects are the blue guys. The datasets are the green boxes. If I expand one project, you can see that the project can contain datasets, and then the datasets contain images. Okay. Dataset might be inside a project, but it doesn't have to. I have few datasets which don't belong to any project, such as this siRNAi HeLa dataset, which you, ladies and gentlemen, have in your portfolios as well. So you can explore with me. I can, for example, select an image such as this one, and this one has 40 Z-planes, and it's called Scrum 16 .r3d. I have here in the right-hand side, when I selected that image, some basic metadata already, which were read by bioformats during the import process. This was the second blue bar in OMERO.insight right here. Okay, so during that import process, the metadata were read, and the most important ones are displayed here, such as pixel size, the type of the images, how many Z sections are there, how many channels, and what's their name. And then some further metadata are stored in the under the acquisition pane. These are the original metadata, as the name says here on the harmonica. And again, these were read by bioformats. Basically, if it's in the original file, then bioformats will read it. If not, then of course, no chance. And these metadata typically we don't encourage to change, but I will show you in a second how you can add additional metadata post-import, which of course you will and want to do in let's say, the client or otherwise, to post hoc annotate your images. The original metadata might not be easy to read like this. That's why we have a we have a OMERO model where we have simply a schema which says what, for example, a numerical aperture of an objective is. And if we find in the original metadata some value which looks like a numerical aperture of an objective, we will overtake it and then display it, put it into the relational database, and then display it in these harmonica tabs here in a more user-friendly manner. Such you can see under microscope, it's much more benign. Immersion is here. The numerical aperture is here as well as mentioned. Further, we have a preview tab on the right-hand side where you can do first inspections. So just after import, which we just described in full, with the metadata, the typical scientist would attempt to view the images, and for that he or she has to change the rendering settings. This is the manipulation of the slot of intensities which will be displayed on the screen. Okay, we call that rendering settings, and you can adjust it in the preview tab. By the way, if I adjust the rendering settings such as this on this image, watch what happens if I save these unsaved settings. This thumbnail will become more blue. Now it's saved. But mind you, nothing happened with the original file. We did not rewrite the original file. We never do that. Instead, the rendering settings were saved as an object in the OMERO database, and you can imagine them as kind of a pair of goggles which you use, and you can change to view the original image, but the original image stays untouched. Now let's imagine a case where a scientist would stain in the green channel for a protein of interest, and then would like to, then he or she grabbed a couple of images and put them into a data set such as siRNAi HeLa, and would like to know, of course, very quickly whether or not their staining worked. For that, I can switch off the channels by clicking on those boxes here. All except green are switched off. Then I adjust the green intensity in this by sliding the max and min bars. And once I'm happy with this, I can click now on Save to All. All here means all the images inside the dataset. If I do that, then all the images inside the dataset will have now the same rendering settings on them, and I don't have to worry whether or not they are comparable. I know that they are because OMERO made sure that for me. Now, many scientists will encode metadata into the names of the images, such is the case in our case here, and you can filter in the center pane mm, um, for names of the images by clicking on this drop down and selecting name, and then you go, for example, Scrum, which I know these images should be stained, and indeed they are stained, so this looks good. Let's just check my control, which I know is highlighted by the name in, which stands for INSENP. And if I go for in, you can see that the control indeed is not stained. So this looks very good. And in this simple manner, if I remove the filtering by deleting the text, in this simple manner, I can see that my staining really worked, and I needed a very little time to verify that indeed. Okay, what if I again select the image I was before on and think further? So what do we have here yet? Let me show you some cooperation aspects here. For example, I can go and see what other people are thinking about my image. These are the thumbnails on the bottom of the right-hand pane in the preview section. And you can, for example, see that Florence Nightingale, my colleague in the Read Annotate group, has navigated to my image. You know how to navigate to my image, me being here trained one. And she saved rendering settings, her rendering settings on my image. And I can now harvest her rendering settings on my image by clicking on this small thumbnail. Okay, that's the one. And I can say save to all again. And this is train one overtaking the rendering settings of Florence Nightingale on this image. By the way, Florence Nightingale in her portfolio has also the same data set, but it's her images, okay? So there is an image for each of you, for each user, 50 copies of that. This is just for didactic purposes. Of course, this is not the typical situation, it's just this workshop setup, okay? But what I wanted to say is that train one just overtaken the rendering settings of Florence Nightingale on his image. And now, yeah, these are the rendering settings of Florence Nightingale on the whole data set. If I don't like it though, I just think, yeah, okay, great, but I would like to go to the original rendering settings which were there when I started to work with the images. Then I can go and right click on the data set, navigate to the rendering settings and say set imported and save. And it asks me whether to change rendering settings. I say yes. And I am back at the rendering settings which were there when the images were originally imported. Okay, very good. So I select that image again. And I can go now and show you some further metadata. So when we were at the filtering, I'm now back in the general pane. Okay, I can now sort my images like as follows. I can filter in the center pane for metadata such as tags. I can go and say tag, choose tag, anaface, and a lot of images were filtered out, and these images are in anaface. Well, how did that happen? This was obviously not by magic. There was a simple manual step where the scientist, in this case Will Moore, went and identified in Omero which images are in anaface, and then put an appropriate tag such as this one, anaface, in the right-hand pane onto those images. How did he do it? He clicked on the plus, and then you can select, let's say, another tag for colors and pop it into the right-hand pane, and then say save. You can create new tag as well, say save. And I have now two tags on this image, for colors and anaface. Okay, I can remove the for colors tag from this image. Hopefully that is quite clear. And this staining, pardon me, this tagging was done on all three groups which we have here: metaface, anaface, and prometaface. And later, for each best of the each group, anaface, metaface, and prometaface, has the best image which I like the most, let's say. And for that we annotated this best of images by rating 5 stars. So you can see here, this is a prometaface image which is rated by 5 stars, and the rating is manipulated in the harmonica here, called ratings, obviously. Okay, so in this way you can do annotations. I was talking about tags and ratings. Obviously I can multi-select the images and tag them all in one go, or of course I can add more tags in one go as I see fit. Okay, let's remove the filtering for now. And then I have another feature, which is probably our most used annotation type, and these are key value pairs. Key value pairs are in the second harmonica tab on the right hand side, and they look like protocol lab book of a typical scientist in a wet lab, where you have always a value such as PBS, and then concentration of the PBS as a value, or you can have a key called, I will select now 2 images, okay, using control, and click, I will add a key animal, okay, and a value rabbit, okay. So you can see now how it works. I just added the key value pair to those two images. The key value pair will be nevertheless added singly to each one. Just the web client is so clever that it shows me it as one, and I can add in one go on 2 or several or 100 images new key value pair. Each of them now has its own key value pair animal rabbit. This one here and this one here. And I can now search for this key value pair using a specific search. I can start typing animal colon rabbit. I have it already here, animal colon rabbit. And this says to the search, which is on the top right, it says, just show me, please, the key value pairs, specifically key value pairs. This is signified by the colon. And key must be animal, and the value of that key must be rabbit. Okay, I click enter, and then I am in the search environment here, which has unsurprisingly 2 results. And I have now, if I click on that verification that indeed this has a key value pair animal rabbit. Okay, so but I now realize that this image actually is not rabbit, it's goat. Okay, so if I change it to goat and search again, obviously I find just one image. Okay, this is the rabbit one. I have to change the value to goat here. If I want to find a goat image, that's perfect. If I want to find both though, then I can remove the value and the colon and then search for something, any image which has the term animal in its metadata, and I will obviously find both. Okay, so you can see there are 4 key value pairs. One of those images has animal goat. One of those images has animal rabbit. You can have them now all in the right hand pane. If I want to return from the search tab um, to the web client to really verify where the image is and see it in the context of other images, I can click on the browse, and that's how I navigate easily back to where I was in the web client. Okay. Now, let me come back to my favorite image here and double click on that image. I forgot something, pardon me. Let's not rush yet. Let's not show you something yet. And these are the attachments. Okay, this is yet another type of annotation, but this one is of a huge importance, obviously. In Omero, you can go to the attachments tab, and by clicking on the plus, you can upload an attachment. This would be most typically something like a CSV with your results coming from, let's say, Fiji or other third-party imaging software, or yet another description of something captured in PDF or whatever you choose. You can choose browse here, then, and from the local hierarchy, I can add now I2K macro IJM. I open it and accept, and this is now added here. I just import it, not imported, but I upload it into Omero a new file and attached it to this image. Of course, again, I could have multi-selected the images, etc. And attached it to many of them in one single step. And now we have the file attached there. What can Omero do? Well, with the IJM file, this is image.j macro file, it will not do much out of the box. But it's stored now for you on the Omero server for the later peruse, and you can find the file by connecting, let's say, Fiji to Omero using the Omero API, as we discussed in the presentation, and then retrieve this Omero, this I2K IJM, which I just uploaded, I2K macro IJM, and the Fiji connected via API to OMERO will retrieve that. IJM will read that because it's its own file type, and read the recipe written there and do some analysis based on that. Recipe inside that IJM file. You can do the same trick with, let's say, MATLAB or any other software, third-party tool which you can connect to OMERO. We will go through that in the analysis section. If you add something which rather resembles a descriptive protocol into the attachments, you can take some advantage of that as well. If it's PDF or CSV, the big search, which I've just shown you for key value pairs here on the top right, will search in those attached files. If that be a text file or CSV or a simple PDF, that content of that attachment will be searched, really indexed and searched by the big search. Okay, so these things
Peter,
can.
maybe Peter,
Yeah.
Peter,
Yes.
before moving forward, I think Daniel was a bit confused about the data storage. I was trying to chat, but in doing that in the chat, but I thought it might be easier to do
Yes,
it via
absolutely.
voice. So there are two things in terms of what OMERO will need. If you OMERO is a software, so if you some kind of software platform, but if you have data that you have going to import data on a machine where OMERO is running and put those data, that when the import we were showing earlier on via Insight, you move data in that case from your machine, from one machine to the server machine. The server machine will require some space, obviously, depending of the volume of data you are going to put in there, because you are physically moving data from one location to the other. When we were showing the in-place import, the data are usually in a file sharing system, maybe a Samba share, and in your institution, the data do not physically move. So wherever OMERO is running, the data don't move from the initial location where they have been put post-acquisition. In that case, there is just a link between the two, and OMERO could sit on a will require less storage. You will still need some space for running the Postgres database and various thing, but it will not require the storage needed to store the images. What will be stored in that case in that OMERO server will be the thumbnail, the thing that Peter is showing in the central panel, and all the attachment, like in the thing that Peter has have, a collection of PDF. Those one will be stored in that server, in that OMERO server, but the images could live elsewhere. The physical raw data will live completely somewhere else. As long as OMERO is about to know how to point that. Maybe you could show, Peter, if you scroll at the top where the link when there is an in-place import look like, because there was also a question of how we could fix that. No. From Sylvie, the question is no. As long as the volume where the data are living are for the in-place import, as long as where OMERO is the server that OMERO is sitting on and where the data are sitting on, there could be a different server. As long as the volume where the data are sitting on is mounted, and it's a bit like when you, I don't know, you put your USB key in your computer and you can open an attachment. It's the same paradigm.
Actually, I can show that to you. I was trying to show it yesterday. Well,
yeah, that maybe, but they do not necessarily sit in the same physical location. As long as one you can connect to the other, and you know how it works, that would be fine. We probably need to not to do the terminal, Peter. So is it clear? Does clarify a bit more the information? One thing that Sylvie suggested, we have some of the example, but we didn't publish them. Peter, can you show remove your terminal, but the web is the ability, the in-place import, you can see the path, blah, blah, blah. Okay, in that case, is the ability to update that path if the user changed that. And I think we have some example script that we have used internally, but we have not published them. But that's something we need to publish for others, because that will happen. That could happen if the user is not careful. And a mechanism to reconcile the paths. You could have cron job that run through the entire system and say, okay, are the paths still matching, etc. And send some alert mechanism. But if you know that some images have been changed, the ability already to fix those paths, and that will be done via the API. You don't have to directly go into the database and enter manually the value. We can do all that via the API, and we will we'll publish some of the script that we have for our use. No, when the pass in that case all the data have been imported in place. Maybe you could show the new one you have imported, Peter. You will know exactly, you know, the imported in place. You will have something like transfer ln underscore s, so like the type of linkage we have done and where it is, end up on the server. If you import one from the one you imported via inside this morning desktop, if you look at that, the path will, you know, it will telling you, okay, that was imported direct, you know, it coming from Peter's machine, basically, and they were physically moved. So you will know where they came from, but when the in-place import, you can identify which one, if they're an in-place import. So that when you do a script, you can distinguish the two, and then we could check, okay, is there still a file at that physical location on the volume where the data are, and reconcile thing if something got broken, or at least send a report to the script could send a report and say, okay, out of those 100 files in the system that were in place imported, 95 still have the correct location, 5 got moved. You may want to fix those one, otherwise the user will still be able to see the thumbnail and retrieve all the annotation and everything that I've attached to that image. But when they want to view that image, like in the full viewer that Peter is going to show, they will not be able to do so. If the original image is changed, moved, you mean on disk. So there are two things. If the origin, by change, do you mean move location? Christina, is that correct? Feel free to, if you can speak to.
Okay, it's easier. Yeah, instead I'm not good at like typing fast.
No,
like
don't.
if you update your image, let's say it hasn't been imported in place, right? And the user updates their images, changes their images, like all this, or move them for that matter. Does it automatically update? Because I mean, I guess you have to go manually update. Like, you know, if you want those changes to be transferred in Omero, you just have to reconnect it.
In the original file, you mean?
Yes.
What happened is when the in-place import or an import happened, the metadata are read during the process, and those metadata are stored in the database.
Okay.
The original file stay as it is. We've been working on mechanism to re-update the metadata, especially for that problem. Let's say we misread some metadata and we don't want to re-import. So we have been working on that to readjust the metadata. So that's kind of what one will have to do. Like in your case, let's say some more metadata were added or misread during the process because there was a bug in the library. Then we have worked on that to allow to keep the imported image into Omero and read that image again and fix the metadata that were wrongly imported.
Okay, cool. That's what I was asking.
Yeah, because in that case, you don't, let's say if you have already done some annotation on that image, or you don't want to repeat all that work. We have
that was my thought exactly. Yeah. Like
yeah, but we have already
worked on it.
We don't have time to show you everything, but we have mechanism to, I don't know, copy knowledge from one image to the other, change ownership, and change group. You can do quite a a significant amount of things afterwards. It's not like because the image were in many cases, you have a student coming to the lab, they do some acquisition, they leave the lab. You do not want to lose that work. You want to pass it on to somebody else, because depending on the level of permission, it's only the student will, for example, allow to delete certain thing. Then since that person is not there, you want to pass it on to the person taking the project on. We offer a lot of flexibility like that, so you don't have to then again start from scratch. You can pass it on and keep that knowledge.
Perfect. Thank you.
Yeah, please do not hesitate to, if you are able to chat, just do not hesitate to interrupt. We should have said that at the beginning.
Yeah, maybe one more thing to bust this this concept where you sorry.
There's a question.
Could you show again how to in place import? Is this only done from the web or also in the client? Okay, so this is no and no. Okay, I never showed you how to do an in place import. I did not do it. I just showed you a short schema. You never saw. So there is, so the question, like, can you again show how to in place import?
Maybe
no, because I never showed it. Okay, the in-place import can be done only via command line interface. Okay, and I never showed it.
Yeah, it's a bit more involved. I think it's you need to you pass command like when you do sim linkage, in a sense. There is no import in the web. What Peter is showing in the web is the result of that import, indicating what type of import it was. The reason we do not have it in the desktop client, because we didn't want people to start doing in-place imports, let's say from my own laptop to the system, because when my laptop go offline, that image no longer available. That type of in-place import is only, I would say, you can only suggest that when you have already an infrastructure in your facility with let's, as I say, like a Samba share where all the data goes from post-acquisition, and that's what makes sense, because the IT, you will have the IT will back up those data, will probably move them on tape at a given point in time, and that's not something you want to lose when you start using OMERO, because OMERO, when you put them into OMERO, there is no, the backup is not something automatic. This is also your responsibility. But if you have already a shared system for putting your data, an in-place import is certainly something more suitable. Because when the data go on tape, it's similar when you try to first access them. It takes time to recover them from tape, but the link is still there, and in the sense that the file handle is still there. The data are recovered from tape, and then the OMERO will be able to view them again. So it is you are going to have a bit of a lag, but you will have that lag even if you were accessing the shared system, because the data need to recover. But by the in-place import, I usually put the term, you make OMERO aware of where the data are more than moving them, and so you don't lose any of the benefit of the central storage. So yeah, how it works is basically as the slide that Peter has. You create linkage between the two, but if you are
sorry.
Yeah, go ahead.
When we do the in-place import, in our facility, we already have the server and a backup and all that stuff. And so I'm just wondering if I say, okay, this the root folder where all the user data is. So basically, people go to the microscopes, they acquire data, and it transfers automatically to one folder, and each of them has a folder inside. So this root folder where we have all the data, if we would one day do the in-place import to the OMERO server, every time the user would add some data, this would automatically update the database.
No.
What you will have probably what they have put in Montpellier, for example, they've done. You'll have a job that does that for you. You could have a cron job that scan all the data and import them automatically according to a given pattern. For example, the user the folder name match the login name of the user, and then that will kind of you will need a process that make that linkage happen. It's not going to happen. It's not watching the folder. For that, we had something called Dropbox in the past, but that's a different thing. What you are thinking of is more when people put something into a Dropbox and then that will automatically get imported.
Okay, sorry, maybe just a technical remark. We are 5 minutes into the break. Okay, so what if we say that the other people who might not be interested in the in-place import in-depth discussion go and have a break until half an hour? Okay, meanings half past. This is something like 15 minutes from now or 10 minutes, something. Okay. Can we do it like that? You guys have a break, and we can trash it out with Sylvia in depth during that time. Is that okay, ladies and gentlemen? Or you can simply stay during and have a working break. However you choose, okay? Or if you want to, who is interested in the in-place import to be shown in depth? Who is interested in this discussion? I mean, can you raise your hand or something?
How do we raise hands?
Yeah, I think if you're running, but I put a link there in the Zoom where the slide that Peter was showing. So yeah, basically when you do an in-place import, you will still need something that will make this linkage happen, and that could be a script that you run overnight, and you need a mechanism to watch directories, and that's the kind of approach. There's another tool that, sorry?
There is no, sorry, on your website, you don't have this type of tools available as a plugin or something like this?
Not well, and at some level we have actually the script which I used to import all the data you are now using. All the data, as you saw, are imported in place. So if you just watch my screen once more, this is a massive exception here. Why? Because I imported it in front of you using the GUI of OMERO.insight, and this is not in place. This is not in place, okay? That's the only one which is not in place. That's why I was showing it, and when Jean-Marie was telling me, show Sylvia what is not in place, I was still somewhere here, and all these images, all of them, this one, all these green guys, and all the images inside them are in place imported. By in place, it means that it has this remark, each single one of them has this remark, imported with transfer LNS. LNS is the link, yeah? This is the soft link. So this is the link which is described in this schema by this one, okay? But this is just a description. I never showed you how to do that in the first place. And the way how to do that in the first place is something like you go into this environment, yeah, and run a command which looks like OMERO import and then you say LNS or something like that. Yeah, don't worry about the syntax. I'm not telling you the exact truth. Yeah, but something like that, and then you hit enter, and it will say you made a mistake. But of course, you can do things here which are called scripting. You can write bash scripts, which Jean-Marie did for me, and this is already kind of automatized. The bash script is capable of importing these images because each of you has an SIRNAI folder here, okay? SIRNAI, this 50 times over. So you can see it's not out of the box, but such examples we do have.
I put a link in the over bash script, the in-place import. But what Sylvie is looking is it's again another on top of that. On that is you will need a job that will watch the directory of the user, and when something new come in, either automatically or at night, that will kick that script basically. And for that, we do not yet have those example script, because that is really depending of the type of OS or machine you will have. So what has been done, and I don't know if that could be a solution because in Montpellier, for example, they started to do they have modified the inside client. Well, it's now in the inside client, the desktop client, and what they have is called an offline import. They have something else running on the acquisition machine directly, and when the user leaves that, and I can give you some more information after. I can put that with a collection of link after. Is when the the user acquires the data, they say, I want those 5, 10 or whatever images imported, but they don't want to import right this minute. They want to say, I want them imported. So they select them and click offline import. And there is a job on the acquisition machine that will automatically import them for them on their behalf. Because the reason they do that is that, you know, you only have an hour, 2 hours on the acquisition machine, and you don't want to wait another half an hour for the images to be imported. So that is that option. So what you which type of server do you have where your data are stored at the moment? Because we could maybe look at a cron job for you to actually, maybe as just a showcase of how you could get an in-place import. You can watch some directory, and when something come in, that will come automatically, or even at night, it will say, okay, all the data that are in that folder will be automatically imported into OMERO.
Yeah, I don't really know what type of server we have to tell you, because we
Yeah.
were lucky enough to have the IT guys set up things for us.
But
Yeah.
There's
I
a
think
limit to what they can do or they want to do, and so setting up things like scripts and stuff like this, I don't know if this is something
I
we
think
do.
if we have this type of in-place import element showing the only I would say having them to make cron job shouldn't be a difficulty, a problem. The only thing is after where to cache the credential for the person doing the import on the behalf, where they will have to hide in configuration file, you know, what is my login or session ID or something like that, persistent session ID that the script can connect. So maybe if you have some more detail of how you want that to work, we could
I don't know if the
write some
you know
small example.
the Imaris database. You into the folder that you want to watch.
Yeah.
And then whenever something is in that folder, then it automatically.
Yes, so I think in that case you're more in something called what we have called Dropbox. That's on the OMERO kind of server already. So it's not an in-place import. That would mean running Dropbox in a different location, because we have something like that called OMERO Dropbox, where data, as soon as the data go into that box, that container, they got imported automatically.
It's not a Dropbox for real. It can be any location.
You mean
that case,
another Dropbox, probably. You mean another Dropbox. Dropbox is a name, but we mean OMERO.Dropbox. It's not the Dropbox you might be talking about.
Right. So it's not
It's
a Dropbox.
not the
So
it's not the
basically,
Dropbox you know. Okay,
yeah,
it's
no,
some
so it will
other
be
Dropbox.
it's a mechanism that will watch some directory that we have registered, and as soon as something come in, then the import start.
Right.
Don't see, yeah.
And it's an import. It's not something that creates the link.
No, in that case, that's a full import. Yeah. That's the difference. I think what yeah, it's
but you can have it both. You can have both. You can have in-place import from Dropbox. You can set it up in such a way that you can in-place import from Dropbox. I mean, our Dropbox. Forget the Dropbox, you know, the Dropbox with capital D, you know. Just forget, throw it out of your mind now. This is not what we are talking about, okay?
So it would be
powerful
possible
software.
for our users to have a box, which is the place where they put their data, and then the in-place is automatically generated whenever they add something.
Yes, that is possible. You can watch my screen and you can mock what I did. Okay, so go to Omero guides. Hopefully you know how to navigate. It's just if you go to your walkthrough and then search for the word Dropbox. And what you need to do is to simply find the communication, because that is typically in the institutions the problem. As Jean-Marie asked you, what server do you have? Of course, you don't know. I suppose that you are maybe a biologist or a facility manager or something of that sort, yes? And you are not an IT person and you have no idea what Samba server is, maybe even, and what is the environment. But that's what Jean-Marie needs to know in order to, you see, to pass the information, and the information from your side must be given as well, because this is highly institute from institute specific. Okay, and now you are blocked by the information bar. Exactly, and you're blocked inside your institution by an internal information bar where there is the IT world and your world. Okay, but this is not something which we can breach, of course, and that might be also the reason why we don't, don't give it out of the box such solutions, because they are highly specific. And they need the involvement from your side. So what you need to do is probably to attack on a human level onto those structures in your institution and say, okay, look, there is this thing called Dropbox, and show them the thing I'm showing you on the screen and tell them, okay, you can do that. Please, could you tell me how could you install that? Have a look into the code, have a look how to install it. There is a step-by-step instructions, as you can see, how you can do that. And then, of course, there is a link to the main documentation, which is somewhere here in the sysadmin guide. And them guys need to look through that. Or maybe you have some middleman who is running Omero on your behalf, who is not completely IT, but who is not completely microscopist. Yeah, somebody like that must simply make the information, the information and the knowledge flow, and the communication must be there inside your institution. Yeah, but it will not be a magic out of the box solution for everybody like Imaris has it. Yeah, it's not the case. You have to do something on the server, but everything is possible. Yeah.
Okay, but I will look at that Dropbox. It sounds good.
Yeah, the import for the Dropbox, you would probably need a collection of cron job, as I said, to decide which file that cron job, cron job. So that is basically a job that you schedule. You say, okay, I want them to run every day at midnight or whatever, and that's IT will set that up for you. Cron, you schedule jobs basically, and when that kicks in, you say, okay, all the data, I'm scanning all the folder, and then all the new data that I didn't see from last time, then they got put into the Dropbox, and in that case, the magic can happen. They will get imported. So that could be a scenario that you will you can put in place. Yeah. The top link, import link, the last link I put, you will have the various option we discussed today, which are the import from the user environment, the in place, the Dropbox option, etc.
Yeah, just try to read the Omero guides. This will be readable for you. It should be readable for yourself, Sylvia. And then try to say to somebody who knows more about IT, to read that as well and jump from there. There are links to this like kind of more serious documentation. And by the way, the cron job is, I think it's from Kronos, the god of time. And this is because this small piece of software is simply timed. So it will start at 2 a.m. in the morning when everybody sleeps. It just measures time and say, that's my time to start now. I will do the job. And this is not a human intervention. That's what is called cron job. Yeah. So that you are not confused by that. Okay.
Can I squeeze in one more tiny question?
Of course.
Just about the in-place import as well. I mean, if we do an in-place import with a folder, again, we've had this discussion with a folder that has folders inside, what does the import look like?
I didn't catch the very last words.
No, in Omero, it's still hand up with, it doesn't going to make multiple hierarchy in the sense of OMERO. OMERO is still there are two different things. You know, it's not like you're not mounting your file system into OMERO. So that's, you know, if you got Monday, like the month, the day, the hour, etc. So 5-6 level of hierarchy in your file system structure, and then you have the file. When they appear in OMERO, you still have, you could only put it into something called project dataset and the images. It's not going to match necessarily. It will not match the full hierarchy. It's not. It's not like if you were doing using a tool called Fuse, where you can actually see your file system into another context. It will still be the same, same
Basically, if we
same logic.
that contains folders of our users, and each user has their own folder and everything, we will end up with one big folder with all the data.
Not one big folder with all the data. No, no, no. You just saw that I have imported it manually into specific kind of subcontainers, but they are uh, they are created in the OMERO sense. So I simply took it from my world. My world is like your Samba share, where there are users in my world. I just watch what is happening here on my screen. There is a folder called desktop. That's my local hierarchy. Okay, it says users Pivalcisco desktop. Okay, if I would be on your Samba, on the server, on a big server where your users are, where there is the root folder with the users, then there would be a subfolder under users, which would be Pivalcisco, and another Guyader, pardon me, and another J Burrell, okay, etc., etc. And then I took it from this, and there could be, of course, subfolders. Sorry, I don't have here. It's a little bit flat hierarchy, but these subfolders are not necessarily respected by OMERO during the import. You saw what happened here, yeah? I can create a new project, a new data set, and this is a new
We're in
determined
the
step.
situation where we have more than 2 layers.
You
It
cannot have
will
more than
take,
2 layers
yeah,
in OMERO.
if you have more than 2 layers, it will only pick for the you could say, okay, the data set is just a layer, the container with the images and the layer above, and the rest, if you want to start mimicking and allowing user to do that, you will have to probably make each folder a tag, and then people searching via that mechanism. That is a possibility, but you will lose the. Yeah, it's not an infinite hierarchy in terms of OMERO.
Is there a possibility to do this tagging automatically?
Yeah, everything you can do can be automated as well. So you could say, okay, I'm getting the, because there is an application called tag search that we don't have time to show today, but it's the same. You can automatically say, okay, each folder become a tag, and then I will
Okay.
create a tag, and then you can add that to the image itself, and then in the tag search, people tag, I don't know Monday, September, whatever,
Okay.
and to 2020, and then you will find all the images that have those tags. So that could be a way of creating an artificial hierarchy.
Okay, but we have to be aware of time. In the meantime, we conveniently pass through the break, and we are 10 minutes into the new session. So I'm not sure how the other ladies and gentlemen are feeling about it, because in case they are not totally interested in this discussion, we are more than happy, Sylvia, to stay longer on this call for you, or do it in the second break, and I can show you the auto tagger which Jean-Marie was talking about. Yeah, can we do it like that?
Okay, thank you very much.
Because I don't want to lose the other ladies and gentlemen here. Maybe they just have another emphasis, and we are indeed 10 minutes into the second session already. Yeah. So we do have and I am able to show it. You just have to invest a little bit more time and stay with us here or something like that. Yeah. Just bear with us. We can reconvene in the second break. Yeah.
Yeah. Thanks.
Okay. Okay. So let's go ahead with the normal with the plant program. I was showing you the attachments and the stuff on the right hand pane, and then we wanted to show you the full viewer, which we didn't manage before the break. So we have here, if I double click on an image, and please select an image which has 40 planes, I am selecting the Scrum 06, and I'm opening it in a full viewer. This is called iViewer of OMERO, and then I have the other images from the same data set here on the left hand side. Yes, you know these rendering settings already. So if I go and click on the ROI tab here, I can have here ROIs. I have some of them already there. So I can, let's say, delete them so that you are not confused by it and start from scratch. I can so first of all, this is a 2D viewer, but it can, of course, plane by plane view the Z-stacks and time lapses. So if this would be a time lapse, which it is not, then I could scroll along the time here on the bottom, and obviously I can scroll through the Z on the left. Yes, and I can create new regions of interest. Such as I can click on this rectangle and then click, then I let go the mouse button and drag the mouse a little bit, and then I click again. If I do so, the rectangle is there, it's not saved. I can save it like that by clicking on the save. Yeah, the rectangle is associated with the Z plane 19. And if I now scroll to another Z plane, then I can draw another shape such as line, and then I can click and draw the line such as so. Now, if I now click back on the rectangle, then I jump onto the other plane where the rectangle is associated with. Okay, I can. So I was always clicking but not dragging. I click and then I move the mouse. Yeah, did you manage to do that? Somebody? If somebody is alive there, hello. I can also do the freehand drawing using the polygon tool and the polyline tool. They are the second from the right and the third from the right. If I for example select the polygon tool, I can do a normal polygon by click again, move the mouse, click again and move the mouse like so. Okay, and double click and finish. That's fine, but I can do freehand, and this is done by pressing a shift. Yeah, with the left hand, I'm pressing a shift on my keyboard, and now I click and really drag. I'm not letting the mouse button. I can't show you my finger on the right hand side because I'm holding the mouse button here. Yeah, and then I let go, and then the freehand polygon is shown. So now I can click through my regions of interest. Each is associated with another Z plane, and I can save them all again. Okay. I can disassociate, let's say, this polygon from any Z plane by clicking on that lock. Now, if I scroll through the Zs, that polygon will be shown on all Z planes. I'm sure that you know such ways from Fiji, let's say. Very good. And now I can do some simple image analysis. And if I select, let's say, those three regions and click on the ROIs and then export as table CSV, then I can download the CSV, open it with Microsoft Excel. And I have here a simple CSV which contains the information about the positions of the regions of interest. And yes, so the freehand polygon has quite a lot of points to define it, and this is the definition of the rectangle and of the line. Okay, so if I have if the channel was on, then the line is pertaining, each line is pertaining to one channel, and the and the shapes which have area encompassing an area, then of course I have the areas, and for line I have the length. Okay, so in this very simple, and some intensities as well, like min, max, and mean intensity in this region of interest will be exported in that CSV. In this way, you can do a simple analysis in OMERO, and that's what comes out of the box from OMERO. But we don't, we don't offer much more than that, except as if you switch on the third-party tools. Okay, and this is what we are coming actually to in this section. Then let me show you quickly just the other interesting feature in OMERO.iviewer, and this is the multi-view. So many of you might know in softwares there is thing called split view. We don't have it in iViewer, but if I now drag and drop, it asks me if it should save Royce. I say, let's say no. And I have I just grabbed that image and dragged and dropped it somewhere out with the viewer, the viewport here. And when I did so, it opened a new viewport for me. And I can now do a following thing. I can make this viewport to be a green channel, and this viewport to be a blue channel, and go like that. And now I have something like a split view. Of course, I could repeat it several times, have the other channels here. If I move the viewport with the blue channel now, then you can see that it's not synchronized with the green channel. I can change it by saying, clicking on the top left icon and select the first synchronization group, which is signified with the first lock. And if I do it in both channels, I can now verify that if I do the first action, they are synchronized now. So I'm scrolling my mouse wheel, and this zooms them in and out in sync, as well as if I move them, that's in sync. And if I change the Z plane here with the slider, then the two are in sync as well. Okay, you can see that they are working in sync. And what is synchronized is highlighted here with the checkboxes, with the blue checkboxes. Okay. The other thing which is interesting in iViewer is the big images. You can open a very large image like this, and you have a bird's eye view here. And this is a pyramidal image with many zoom levels. Okay. And if you have ROIs and you are zoomed in quite a lot, I have the table of ROIs here. And if I click on the line, you can see that the viewer jumped like miles away where I was to navigate to that ROI, which would be very difficult otherwise to achieve, because I would have to zoom out and lose my bearing and not see the ROIs in this big zoom. Okay, so this is a circle in the middle. Very good. So much for the OMERO.iviewer, and let's now draw our attention to the third-party tools, to the analysis tools. Okay, so first of all, I remind you what we have here. So we have a server which is remote here in Dundee, and then we have a local application called Fiji. Okay, I hope that you all know Fiji, ladies and gentlemen, and we have a plugin for Fiji. This is like a software glue which uses the OMERO API, and it runs under Fiji. I sent you an email previously saying that you might be interested in installing Fiji, and if you've done so, that's the moment when you please start your Fiji and work with me on that workflow, which is again described in the OMERO guides and in your workflow. Okay. So first of all, the most primitive but the most important thing is to show you how to do a simple analysis producing regions of interest, measurement results in the form of table and new images, and how can I harvest those three most interesting components and from Fiji and put them back to OMERO. So step one, I get my image out of OMERO into Fiji environment, do my magic with Fiji on it, some analysis producing regions of interest, measurement tables, and new images, and put those things back to OMERO to an appropriate place. How do I do that? So I first of all had to install this glue, this OMERO plugin for Fiji, which is described in the walkthrough how to do that. Let me just allow myself to jump to that walkthrough. So for example, if you go to the OMERO guides and click on the Fiji icon, here is described how to install the OMERO plugin for Fiji. So if you follow this walkthrough, then you will get in your plugins folder of Fiji such a new item called OMERO, and I can click on connect to OMERO. This resembles OMERO.insight, but don't get phased by that. It's basically because we took OMERO.insight, or Jean-Marie took OMERO.insight and wrap it as a plugin for Fiji. Yeah? But we are basically in Fiji. Once more, note it, Fiji is the boss here. Yeah, and I log in again as train1 and to the same server. Unsurprisingly, I will see, don't mind the console here. Yeah, that's Fiji is talking to itself. And then I have here the same hierarchy as previously. Obviously, I'm connecting to the same server. And now if I open from the Fiji dataset here, the first image, okay, with double click, then first the bioformats window appears. I say, okay. And now the image is basically fetched from the server into the Fiji in full, okay? This is not the case in the case of iViewer. You maybe saw that the opening of image in iViewer was much faster, and this is because iViewer does not fetch the full image. It fetches only what you need, okay? So in the web browser, when I clicked on the image in OMERO, things were faster because it is using OMERO API, and if it's a 40 plane image, then it would take just the plane you are viewing right now, and all the 39 other planes will stay nicely in the server down the hill at the University of Dundee. Okay, this is not the case for Fiji. It must fetch the whole thing. But for that, once it's done, this image is fully in Fiji. So all the power and magic of Fiji with respect to analysis, which is very superior to OMERO analysis, is capable to be unleashed on this image. And let's just do a small, simple thing. I can, for example, draw a region of interest on this image, something like this, a very funny region of interest, so that you can remember, okay, this is done now. And in Fiji, if I hit T, then I add this newly drawn region of interest into the ROI manager. This is necessary for the next steps of the plugin. And I mean now the OMERO plugin for Fiji, which is running here. This is all in Fiji, yeah, locally on my desktop. Now I can click inside that ROI manager on measure, and this will measure inside Fiji again some parameters out of this region of interest and put them into results table. And I can now harvest the region of interest and the result table and put them back into OMERO. How do I do that? I can go to plugins, OMERO, and say save ROIs to OMERO. I am saving ROIs and measurements, and they are called I2K dash second run because you are the second workshop on I2K on OMERO, and say save. Now it's saying saving, and the goodies will appear here on this image. This means the region of interest and the table, and I can, it says results saved. I can verify it in the OMERO web client. If I go back to where you are hopefully still logged in as well and find the same data set, a Fiji data set, I can click on here. Here is a ROI counter. It says 1 ROI. Great, this looks good. I can open it in iViewer. Yes, this is the region of interest I just drawn in Fiji, and this was now saved in one click into OMERO. That's great. And I can also verify that on the attachments, there is a new attachment called I2K second run.csv. Unsurprisingly, if I click on that, as I say, OMERO will do nothing with that, but it will download to my local hierarchy. I can open it with Microsoft Excel, and voila, this is the line which is coming from Fiji, but this time already saved in OMERO safely for me on the image of from which the analysis was done in the first place. And having done that, I can go on and perform a workflow which would produce a new image. I will close this and I will select an image number 4 in this data set and open it again. Again, it gets fetched from OMERO into my locally run Fiji. And if I've done so, I can draw a rectangle on that image. And because this workflow is intending to demonstrate the capability of creating a new image, I am not now putting the ROI into ROI manager. Instead, I go image crop. This is probably the easiest workflow which produces a new image for me. And this cropped image, by the way, OMERO cannot do crop out of the box, but Fiji can do it for me. Like this. I can go now, and this newly created image I can immediately import to OMERO by saying save images to OMERO. And done so, I can select, let's say, the data set. Yes. Okay. Yes, the Fiji data set. And then I can add to the queue. But the Fiji dataset you can see is the dataset from which the parent of the crop is coming as well. So now if I import it, I will expect that I will have 5 images in the dataset. I add to the queue and click import. Again, you will see the 2 progress bars as we described already. So yes, you can import stuff using Fiji as well. Then I can go back to the OMERO web client, refresh, and indeed, these are my images. This is the original image from which I made the crop, and this is the crop which is coming from Fiji. So I can again open it in full viewer. Great, my crop is here. So I just shown you how you can easily do in Fiji regions of interest, measurement tables, and new images from an image coming from OMERO and save the results of your analysis in Fiji with 1 click. Great. So this is now done. And if we want to get a little bit more fancy, then we could go a step further and do something which resembles a little bit more real image analysis, such as if I let's say open again the first image, okay, then it will demonstrate for you in the first place that I can do a 2-way trip with the ROIs. So the image will be now open with the region of interest, which is now coming from OMERO, remember? Okay, I drawn this ROI first in Fiji. I exported that ROI into OMERO on the same image. Then I reopened that image again in Fiji, and it has, unsurprisingly, the OMERO region of interest in it. I'm not interested in this region. Nevertheless, I will delete it in Fiji. And I will go ahead and do a workflow which is described in your walkthrough as well here. And this is this one in Fiji. I'm going through the segment manually OMERO data using Fiji image J. Okay. Here is some simple walkthrough where I'm segmenting the centrioles highlighted on this super resolution microscopy image. You can see 2 of them here in the center of the image, and I simply want to segment and measure the resulting regions of interest, their diameter from Fiji. Okay, so this is my goal with this batch of images. I have 4 of them here in this data set, but they are coming from a bigger bunch of images coming ultimately from the image data resource IDR, where there are 414 of them, and they are connected to a scientific publication. Very good. I can go now and say, type 8-bit, okay. Thinking about which I actually want to go again and show you how to be more proper. Okay, I could do that, and then let's say trying to remember, and of course there is a lot of trial and error. But in Fiji, if you happen to know, ladies and gentlemen, there is a function called record, macro recorder. Okay, so I can record the steps which I'm doing in Fiji for later peruse for other images, and that's what I will do. So I open the image, I will go to plugins, macro, and record. Okay. Now, if I do my first step, which is image type 8-bit, the step is recorded here in the macro recorder already for me. That's nice. Now I need to threshold the image in Fiji. These are all Fiji steps here, yeah, I'm going through. So if I go to adjust auto threshold, then I will need to leave this white objects on black background, and depends on what version of Fiji you have, whether or not you need that or not, and check the stack here. And I say, okay, you can see it was successfully thresholded. And with this thresholded image, binarized image, I can now go and use the plugin called Analyze Particles within Fiji, such as this. I know that I have to go with 10 to infinity. I have to go pixel units, and I have to leave these 3 boxes checked. By the way, of course, this is a result of a painstaking work on this workflow. As you might imagine, with every image analysis, you want to do something like that, because you have to tailor your workflow according to the images you are working with. And then say, okay, process all 3 images. You say yes, save one measurement which was lingering there in my table. I don't want to save that. There is another very important line added to my macro recorder. And you can see that I have created some interesting regions of interest. In Fiji, they look already much better than the funny region I just drawn by hand. And I have 3-channel image. That's why you can see the slight mismatch, because the ROIs are in all 3 channels. And now I can simply go and save the ROIs in OMERO that manually. That would be nice, but ultimately not that interesting, because you already saw how to save ROIs in OMERO into OMERO manually. What if I want to go a step further and do the batch analysis, which I was preparing my guns for here with the recorder? So I can now go and let's say create the macro which I was intending in the first place, by saying create in Fiji, and then file, and save as, and it suggests that the macro, that should be called macro IJM, and it will save it on my local Mac, because that's where I am with my Fiji. So I will say that this is I2K second run Fiji macro, and I will save it to my home folder. Okay, that's great. So this is my recipe. These are the steps which I would like to repeat on 414 other images in Fiji, but the images are of course in OMERO, yeah. And I want to do that in an illustrious manner, so we will use script for that. How can you do that? Well, you have here if you go to your OMERO guides, you have here another workflow which is called segment OMERO data using the scripting editor in Fiji. And if you click on that, then you can see that there is a script here straight in the resources. You will of course like to read the whole thing through, but just for the sake of sparing time, I can simply click on this and it downloads a script for me directly. I can save the file, and if I save the file, I can open it locally in my text editor like this, and now I can study the script. So the script is basically a Groovy script. Groovy is something like Java. Jean-Marie helpfully wrote that script, and that's why we can offer it for the participants of our courses. And you can simply do what I'm suggesting here on your side. The script will connect to Omero and start fetching the images and create the regions of interest on those images and the results tables resulting from measurement of those regions of interest, also in Fiji. And going through this, it will save the appropriate regions of interest to the appropriate images. Okay, so if you simply go grab that script and run it in Fiji like so, that you go to Fiji and open new file, new okay, sorry, of course you really have to be in Fiji. File, new script, then a script editor will open, and I can, let's say, go and copy the whole script and paste it into the Fiji scripting editor, and then select a language saying Groovy, and then run the script. Okay, but I will not do that because I have something better for you. If you let's say go to the third chapter here, segment OMERO data using Fiji run headlessly in the notebook. If you can click on the on this link in the step 6 of that walkthrough, then Binder will start and some magic will happen. So let me talk you through that whilst the Binder is building. Okay. What is happening here? If I select the script and
take some time if it's building.
Yeah, last time we were quite lucky. That's all right, but you will forgive me if it's not built in completion. Main thing is that you understand what's going on here. So the script, okay. I have basically this script, which I just downloaded in 2 different environments. Okay, the first environment, which I was suggesting here and showed you, is the environment of the Fiji scripting dialog. But this is still running locally on my machine, and it's completely dependent on the vagaries of my local Fiji. What version of local Fiji do I have, which is sometimes upgraded, etc. And it will be fetching the images from the server in the university one by one, and then running the analysis on them, and then basically saving the regions of interest back onto those images. And just there is kind of a long wait, which is caused by the fact that I'm locally here on my broadband in a private flat in Dundee. Okay, whereas if I create an environment somewhere else on the cloud, then at least I will I will bypass the broadband connection, which is sometimes not that great, and I can run my Fiji on the cloud, which is just happening here for you, and then fetch the images from the server, which is remote, to a place which is remote. Now I can go one step further, which we plan to do in the future, and have the cloud place simply closer to my server, something like, you know, having it on the cluster or something, and have the analysis run close to the data where the data sits, so that the transfer of the data between those 2 places is not so long. Okay. So in the meantime, we can have a look at the script. How is it laid out? So I just described to you that it's creating tables and results with results, and also new regions of interest. And you can see here that the bit which I was going through and which is recorded in the macro here in Fiji, which goes something like
Yeah, the key part there is always the same logic. You first need to connect to OMERO. You retrieve the data. In that case, open image. No, stay where you were, Peter. Go down, go down. No, you were at the core. I think going through the no, what you were showing just stick there. The logic is the same. You retrieve you connect to OMERO via the API. You load an image or a collection of images, a data set. In that case, if you're not familiar with Groovy, it looks maybe a strange thing, but it will iterate through the images, open the images that you want, and in that example, you load all the images, the entire 5D object. And if you are interested in only loading a given plane, sorry, my video is off, as Peter was indicating, when you have when you were viewing an image in the web, we're loading one plane at a time. You can also do that if you want to only analyze a plane or a given channel. You can do that. We have plenty of example of that. And after that, you apply the macro. Here, you run line by line the macro. But if you have already the macro as a file on disk or an attachment, you can just say run macro, and then you will apply the macro to the image. What you do in the notebook that Peter wanted to show is something a bit more user-friendly than that if you're not familiar with the scripting facility. And after that, when you have all the result from Fiji, the other key part is to upload the other result. Can you stay where you were, Peter? Yeah, then you save the ROI. You convert each time when you have in an application, whatever that application is, you need to convert the ROI from, in that case, Fiji into OMERO, and then we save them back. Each language has its own, there is no common ROI language. We're trying to work on that but we do the same with other software, like Peter can show the QPass or other third-party tool. They need to be converted into the original form and put them into, just stay on that page, and then we move and associate it. Then after that, we upload the results. So if you are familiar with scripting, or somebody in your institution that is familiar with scripting, we have plenty of this example. And after that, you can slot the macro you are interested in. If you're not interested in thresholding, but in another Fiji plugin, this is basically the only section that Peter has highlighted that need to change. If you want to save, you may not save ROI, but if that plugin generates an image, you can also import that image into OMERO. We have offer quite a lot of flexibility there. Thing is, if you're not familiar with I don't know if any of you do some scripting, but if not, you might have somebody in your institution, and all those scripts are in the guide. All those examples are in the so if we go to, let me put you a link. So I put a link in the chat. This is the entry page, but on that entry page where you see the Fiji icon, if you click on the Fiji icon, the various icons are the various tools we have already integrated with, like Fiji, Elasticsearch Profiler, TrackMate, and other. And if you click on Fiji, it's detail of how to run all the script and how to write. And most importantly, you will have access to in the repository. There's a lot of, in that repository, there's the next link, there's a collection of script that you will find how to access the data, basically, how to use the API. There are several examples of that, how to crop an image, how to do local import, how to do background subtraction, and so on and so forth. Yeah, those are just a collection of examples, and I think you can take it from there in order to adjust it to your need. But when key part there, when you do the analysis, is the analysis is done on the client's machine, that is on your laptop, or where Fiji is running. So the data need to be transferred from the server to your local machine and sent back. You could argue, okay, it would have been quicker to have only the machine, the data directly on the machine. That's true. But the advantage of using OMERO is then you can also control, you know where the data are, you have the data accessible for further use, and we'll show you something, another tool afterwards, where you can actually use the tool elsewhere. And another advantage, and we have colleagues in Dundee that work that way, is they do analysis in one software. In that case, they were doing the analysis in Python, doing some tracking in Python. They save the result into OMERO, do the attachment, and do further analysis in R, but at least they have a better control of where the data, where the analytical result end up. So Peter, do you wanted to show another tool, maybe?
Yeah, maybe we can in the meantime go and
your image will take ages.
Yeah, just the sequel to what just Jean-Marie told you about the that the analysis is running where the Fiji is, so you have to transfer the data between Fiji, and so there are several ways how you can put the analysis closer to where the data is. I was already highlighting that you can manipulate, of course, the place where your Fiji is. I mean, I was just showing, and we were discussing with Jean-Marie, you know, I can have it on a kind of a remote place, which is my laptop here under not so good broadband in a private flat, or I can have it on a cluster which is close to this OMERO server, and the connection between them is, let's say, on the university network, which is much better. Or I can indeed run some analysis scripts directly on the server, which is the thing I'm going to show you right now. Yeah, so I have here in your walkthrough, there is a chapter called server-side scripts, and that's what I'm going through now. In the web client, it is in the web client, the server-side scripts are hosted here. What is that? So you can have scripts which are directly on the OMERO server, and they can give you, of course, orders of magnitude better power and performance to the tools which we were just exploring in OMERO. In OMERO.iviewer, and out of the box you have quite a few of them. Some analysis scripts like Kymograph and similar. So if I, for example, show you the Kymograph script user interface, which is described there, you can click on a script which is called Kymograph, and you have a form to fill in like so. So it looks for a Kymograph on this image, which doesn't make sense. If I go to better image, let's say I select this image, which is a time lapse, and I click on Kymograph, it makes better sense. And then I can run that script and it will create a new image called Kymograph. Okay, so this is how it looks from the user perspective. It looks pretty easy. It is pretty easy. It works quite fast. It will create a new Kymograph image. This is basically an image composed out of the pixels which are underneath a line region of interest, which is done on this image. It's done already. You will see now I have here 10 images. If I click on this icon to re-navigate, now I have 11 images here. This is the new one. That's how quickly it went. And now I can do some Kymograph analysis with a follow-up script. Okay, so I have again analysis, Kymograph analysis. Very good. And then I have to draw, if I would have to draw, I have drawn a line according to the other analysis. Then I would have some CSV results, which I can study later. Great. So Kymograph, let's leave that aside. Maybe you are not interested in Kymograph. I've never done it myself in my wet lab career. So let's not hammer that down too much. But what the main point is that the script can do fancy analysis for you. It does it on in the same environment as the data are. So there is no transfer of the data between the environments, between the analysis and the OMERO environment. And you can, very importantly, you can easily write such scripts yourself. So you have this a small user interface which pops up when you click on the script. This is a form, a kind of matrix which you can simply manipulate and change in the script as you see fit. And you don't have to program this user interface. And then you can create quickly your new script called my-script.py. And yeah, let's say the data type which we would run on is not image but data set. You can simply change those items here. You can say, of course, that this item is not line width but area of the square, and use all time points will not be there. Is time increment and pixel size. You can simply create new boxes programmatically using that script. How do you do that? How to start with that? It's easy. You can go and say in the OMERO guides, server-side scripts such as this one, search for that. And if you do so, then you will find the proper chapter, and yes, it will show you how to run server-side script, which is what I just demonstrated, how to write a server-side script. Here is kind of like a hello world example, which really with minimal Python skills, you would be able to follow. And in this walkthrough is described how you upload then such script into OMERO. Well, you can do it using command line as highlighted here, but you saw already in my interface that I have here a button called upload script. This is because I'm an administrator on that OMERO server, and administrator or restricted administrator with the rights to upload script can upload script. The upload of scripts is not meant to be done by simple rank and file users, and this is because there should be some vetting steps, some quality control, as the script can be fairly powerful. It does not mean that the script can be run indiscriminately on anybody's data. Note that it always depends who is running the script. But the danger is if somebody uploads some innocuously looking but intrinsically dangerous script, then a unsuspecting user can click on that script thinking that he is doing the convolution and in fact deleting his or her own images. That's why it's good if I have a new script that somebody who in the position of authority and responsibility has the power to check the script before it's uploaded for everybody on that OMERO server. Hopefully that makes sense. Yeah. And I can now then go and study the, pardon me, I just don't know where I am at the moment, how to write a server-side script. So if I go here, this is the matrix of the script which I was just describing. And if you feel so to write a script for your server, I think you can have a go and then talk to your OMERO administrator. Here is the start of the script. Okay, and yeah. So it's basically pretty easy matrix to follow, and you can simply manipulate the code here and stick in your own features into that matrix of the form of the script, such as yeah. Yeah, such as highlighted here. Okay, so these are the server-side scripts. Then you, of course, would upload the script, and tada, it would appear, let's say, as a new folder, as a new item here, or indeed you could put it into some other folder as shown in this menu, and it's there available for your users, for everybody on the server. Okay, so this would be the server-side script, and I would go now back to this tab, where already my my Fiji is built, so I can now show what I was building for so long in Fiji, pardon me, in my binder on the cloud. I just started a small machine where there is Fiji wrapped with that, and once I did it, you saw it took a small while, but after that I have for free, if I start this desktop,
So
I will.
yes, I think it's a nice way if you, when you publish data, you know, sometimes people say, I analyze my data with X, Y, and Z, and it's very hard for someone to be able to reproduce that analysis or even to set up the same environment. And I think that is you're not going to do in terms of the in public cloud-based structure like Binder. We on the side project we are starting hosting our own system ourselves to offer more resources for that. But it allowed you to show what can be done against your data. Let's say you publish when you put your data, they don't have necessarily to be in Omero. In that case, they were in Omero, but they could be available in Zenodo or somewhere else where you have put them public. Obviously, some of the code will be slightly different, but the gist is there. You can then offer in a notebook there, you put them into a GitHub repository, because what happened here is one of the the last link, Omero guide Fiji, you copy that link into my binder, that what Peter did, and it generates an environment for you where you can then run, in that case, Fiji, and run some macro connected to your Omero, to the Omero server. So the analysis is done elsewhere, but it's, I would say, it's not heavy analysis. It's more a showcase of element what you want to do, or small analysis in that case.
Yeah, so let's just do it quickly. I started a desktop, so I could have done everything actually in this environment. I didn't have to have the local Fiji here. I could have prepared the full workflow here. That's fine. Now I have also the Jupyter notebook, and the Fiji will be run headlessly inside that Docker, where this Jupyter environment is there as well. It's a convenient environment for executing code, so you don't have to get too worried. I'm just clicking through those cells using the run. First, there are some class paths to be imported, and once that's done, I will connect from this notebook to the Omero server. Obviously, is the glue script here, which is connecting and ultimately the Fiji running headlessly with the Omero server. And for that, I have to log in. I log in as train1, and okay, I do not rerun the cell. Then I connect to Omero in the next cell. It says connecting, and I made a typo. Of course. Okay, let's try again. Yes, now it was successful, and I select the image. Okay. So the image ID, which I will run on, I will take it from Omero, and this will be one of the Fiji data sets. Here I will use, let's say, this one. The ID is here. Okay, I'll copy it. It has 0 regions of interest at the moment on it. So I will paste the image ID here into the cell, just remove the, okay, then collect the parameters. Basically, it's looking for, yeah, it's looking for an attachment on that image, and I see that I just made a mistake. I, of course, can't use that image. I will use the image where there are some attachment on it, and the attachment which I'm looking for is the attachment which I kind of mockingly created for you. So I would attach it from my local hierarchy. In a previous run, I created the I2K second run IJM macro, and I would attach it to that image by clicking on this one. This would be basically the saving of my recipe from Fiji, so that I can run my analysis on the images now in industrious manner, as we will do right now. But this freshly created I2K second run IJM will not work out of the box with the headlessly run Fiji. We had to a little bit adjust the macro, and the Fiji macro segment 1 is the one I will be using on that image. Okay, so I have the image ID again to grab and copy and paste it into the cell of the notebook, and rerun the cell with the image ID. Yeah, just do that. Okay. Okay. Good. Collect parameters. Yes. Then I retrieve the macro files linked to that image. And I will select the macro to use. You can see that I was successful. Now in this way, actually, this script is, by the virtue of connecting via API to OMERO, is able to retrieve the attachments which you just saw in the web client. And I'm selecting the Fiji macro segment 1. That's great. And then I load the selected macro, loading macro, and it saved it in this environment, loaded it and saved it. And then I will run the macro on images which are being fetched with a logic very similar to the script I was showing to you here in my local environment. It's fetching the images, opening it, running the macro on it, meaning images is just one image in this case. But of course, I could very easily loop in this script, even writing into this Jupyter cell, and loop over all the images in that data set, or let's say over all the images in the 10 data set in the whole project, which was 414 images. And then I can see that the analysis was successful. I have some results tables, okay, which I will save in the next step of this script, which Jean-Marie wrote, and I can select the output to save. So I select, say, image, ROIs, and results, all three. That's great. Then I collect the parameters. Which is basically collecting the results of my choices here from the previous cell, obviously, and then I save the ROIs back to the server. Great, so this was successfully done, and save the measurements associated with that analysis here in this environment in the Fiji, which was run headlessly. And it says saving results as a CSV, true, which looks great. So I saved the CSV in this step, and then I will save the image as well, importing, okay. So this looks like it's still importing.
You were generating with that
processing done. Okay, yeah, so that's fine. That's the new image is imported as well, and I have the ID of the image as well, and the good practice is to close the connection so that I don't tax the resources of the server unnecessarily. And the whole thing was done, and you see how easy it was to analyze an image. And I could have done, of course, in a loop on 414. I didn't have to change a thing, and I have a security that everything will work every time I come to it. And as Jean-Marie highlighted, if some other scientists will come to that, I will be able to, he will be able to reanalyze in the very same environment. I'm just searching for that new image which I just imported. So it's right here in a new data set called Analysis from Fiji. Okay, this is the new image which I just created in the Fiji Run Headlessly notebook, which I was demonstrating right here. And you can see it here in OMERO now. And yes, this is obviously the thresholded segmented image. But more importantly, on the Fiji dataset, on the image, which is the first in the dataset, I have new regions of interest. This is the old region of interest. I will just delete it for now, which is coming from my manual demonstration. But on top of that, I have here much nicer regions of interest, which I'm just highlighting here, which are coming from the serious segmentation, which was done by the Fiji Run in the notebook headlessly. Okay, and the table with the values is attached as well, and this is this one here called 9539 results CSV. 9539 is the ID of the image, and I can open it like this, and I have here some values coming from the Fiji Run headlessly. Of course, there could be many more values, but I just Jean-Marie just set up the Fiji with those values. Very good. If there are no questions, we could quickly try to show the cell profiler if there is interest in cell profiler, and or do something else according to your wishes. That would be just before the break, which is gonna happen at 45, meaning at 1:45. It's 1:45 very soon here in UK. Okay, so are there any questions to the Fiji workflow? And this is basically mainly representing the third-party tool analysis. Are you there? Hello? There is something in the chat. Nope. Good so far. Okay, very good. So we can show, thank you for your feedback. We can show now the cell profiler, which will go much faster. And then we will go into a break. We will make a break this time. I would suggest, even if, yeah, because I need a break myself as well. And after the break, we will show how can you mine the data based on the analysis results which we just created in Fiji or Cell Profiler. We might or might not show QPath, but definitely we will show OMERO.figure, and then we can go in depth of the OMERO in-place import and show the web tagging as well. This would be coming back to Sylvia's question in from the beginning. Okay, so let's just storm through Cell Profiler. Cell Profiler is a very popular image analysis tool with a great power, which is used very often on high content screening data, but also on other images, why not? And we will show the power of Cell Profiler on this data, which are also coming from IDR. This is high content screening data. You can find them in portfolio of Trainer 1, and you can click on one well and you can see that these are time lapses of dividing cells. It's very nice. You can see a time lapse like that in the OMERO.iviewer. Perfect. And these data will be analyzed. We will segment the cells, and on the first time point in the time lapse only to spare time. but I have built the similar environment. This is now basically the same logic, exactly the same logic as with Fiji. Okay, I have a Jupyter notebook Docker environment with Jupyter notebook, which I built on, let's say, my binder. In this case, I did it locally, but you can do both. Once I've done that, anybody can do that. Again, the same logic applies. If I do that, then I can simply click on the notebook here, which is called cell particle counting and scoring stained objects. Okay.
Yeah, in that case, you need to be clear that we're using Cell Profiler API. We're not using the Cell Profiler, the client that you will have. You might only use the user interface. Here we are using it headless again, because that's the most natural way to interact OMERO with a tool like Cell Profiler. So what you will typically do, you will build a pipeline on a couple of images, and after that you will run, when you have a pipeline that you're happy with, on a larger scale and of images. And we follow the same pattern with some people were mentioning Elastic earlier on, is the same in the workflow in the guide. If you look for OMERO guide Elastic, we do the same thing. We prepare things locally first, create a pipeline with a couple of images, and then when we're happy with it, we run it through the API, because interacting with those tools via the API or in the headless mode is much more natural, because you don't have to build a widget into their own UI.
Great. So in the meantime, I run the first cell of the notebook, which are basically importing the libraries and then connecting to OMERO using, of course, the credentials here. And then I'm fetching the plate which contains the images to be analyzed. This is 102. Yeah, can you see 102? And the plate name is plate one underscore 013. And if I just verify in the web, you can see that's true. Yeah, plate 1 underscore 013 with the ID of exactly 102. Yeah, so that's the plane I will be working with in the notebook environment, in the cloud, on the with the cell profiler run headlessly using the pipeline as Jean-Marie just highlighted. So now I will load the pipeline and inspect modules, and I will leave Jean-Marie to talk you through that, because I need a technical break, so he can talk through the modules here.
The pipeline in Cell Profiler are built to usually to work with images on your local machine, but so that's why they all come with the same way. If you have, I don't know if some of you have used Cell Profiler, but if you do, there is always element expecting images on disk. Those are the first 4 modules, and what we need to do is to remove them. What is the important bit is when you see in the screen, when Peter will call it identify primary object, that's where actually your analysis is going to start. The first 4 element is where the data are. In our case, we don't need any of that, because we will be analyzing the data remotely. The data are elsewhere, in the case in OMERO. And Cell Profiler as a module that we'll see below, that allow us to then I don't have let me open the notebook. You can then inject the data as you go in order to be able to so it's Peter's screen. It's fine, he went away, but I can't scroll down, so I'm a bit stuck here, where you can actually inject your data into the pipeline. Has some of you used Cell Profiler before? People are still alive. Okay. So you can do quite a lot of segmentation and do image classification, etc. But I think the gist is to give you, so that's a Python, it's a tool written in Python. So if you can scroll down, Peter, a bit. So after that, the key element here, so a plate in OMERO is a collection of it's a collection of wells. So we're going to analyze the first 5. But the interesting part here, if you scroll down a bit again, Peter, is for each image we are only interested. We are going to analyze the first time point and in OMERO sense, which the advantage compared to the tool when we're looking at the case of Fiji, when you use the API, you can say, okay, I want only to analyze a given plane. So you don't have to move across the wire or wherever you want to analyze the data. You don't have to load the entire structure, especially when your images are big. It's quite important to consider. So here we are going to analyze the channel on the first Z plane and the first time point, and you can do so. The rest, origin blue, origin green, that's part of the pipeline. That's the way to indicate what is what. But the important bit here, the flexibility that Cell Profiler offers, is called inject image. We are going to now replace the image on disk by a remote plane, and then you can then analyze your data. So if you run the cell, Peter, people will see that. Then you have run the you should be at the if you scroll down now, then it starts to analyze the data. Then you say, okay, I'm going to do that well, and when it's finished with one well, it will just do another one, and etc. etc. So what type of analysis tool do you guys use mainly on your images? Is it mainly Fiji, or you have your own script, or MATLAB, or? Because we have bridges with, as Peter indicated, and if you are interested for most of them except MATLAB, if you go to OMERO guide, I don't know, Python, R, etc. If you copy those one in my binder, as we have done, you will be presented with a collection of, or if you go to any of those repository, there's on the README, you will have an icon called launch in my binder. It will create you an environment where everything will be installed, and you will be ready to. What are you doing, Peter? You will be able to. Can you stop clicking on all the tab, because we're sharing your screen, so you're losing people. You will be able, in that case, to get an environment where you can, if you want to explore with R or Python, just replace, like in the link before, could even dash Python, and that will bring you to a lot of notebook afterwards that you can explore and use the credential that we were given to you. Okay, let's, in that case, let's scroll down. The analysis is done, and after that, if you're not familiar, but you can do some plotting, and then you can get the data. But the important bit here is that you can, again, in another language, save the result back to OMERO. So you can, in that case, if you scroll, we're saving all the feature we're calculating feature in that context of that pipeline, and then you can save them back into OMERO. As Peter was pointing at this morning, or earlier on in his slide, because with analysis, you don't know what you are going to get in terms of the number of column, whatever you want to save. You can save in as comma separated value, like we have shown earlier on, but you can save in a much more flexible structure, which is called OMERO.table. It's a bit like a relational database, but not a relational database, if you want. It's something very NoSQL, what's called NoSQL. So it's something quite flexible. The advantage compared to a CSV file is that you can also query it afterwards when that Peter will show that in the UI afterwards, but you can then say, okay, I want to extract, give me all the analytical output that have I don't know, values greater than 5, for example, and then you can extract that. And that's why that the one that Peter has highlighted, then when you save the result, saving the result into that structure offer you much more flexibility after when you want to then mine the data, mine the analytical result. So that's something to keep in mind, because when you do, again, a CSV file, the CSV file, when they are small, that's fine. You can open them into Excel, but when they are extremely big, when you have a lot of feature calculated, that's not going to scale. So that's why you have something a bit more flexible, where you can actually mine the data, ask the server, give me what I want, because that's what I'm interested in at that point in time.
Okay, so maybe just to show what Jean-Marie was talking about, we just executed the cell profiler notebook as Jean-Marie went through with you about it, and it evaluated, analyzed the 5 cells. These are not 5 wells. These are not necessarily the first 5 wells here, and it created a new OMERO table. Okay, these are the 2 OMERO tables. One is from the first run of this workshop, which was done on the 30th of November, and the other is from today. This is 2nd of December, and yes, today is, yes, okay, so 2nd of December. So this is an OMERO table, and in OMERO web you can view the contents of the OMERO table, which, as Jean-Marie highlighted, can be queried row by row in the OMERO web client. If you click on the eye icon, you can see that it has 5 lines. This is because we created in that script previously collated results for each well 1 single line. This is because the OMERO.parade needs for each well a single line. Okay, and the OMERO.parade is the data mining tool, which we will show just after the break. So let's do the break. We will, let's say, I don't know, I have 53 on my clock here. It's time for the last part, ladies and gentlemen. Welcome again after the break. And what we want to do here is we will simply skip QPath. QPath is a nice tool, but yeah. I think some of you might be more interested. Is somebody explicitly interested in QPath? Do you do whole slide imaging and stuff like that, ladies and gentlemen? Huh? Maybe not. Some chat.
Just move to Parade in that case.
Okay, let's move to Parade. We are going to talk through OMERO.parade. Not really. Excellent. Thank you, Christina. Let me just clean the mess. I'm really sorry. So I hope that you understand why am I constantly a little bit lost. That's Fiji. Well, that's fine. These are some walkthroughs. Just bear with me. Now I'm back in the OMERO client. Okay, web client. I click on the data, and I would like to navigate to the data of trainer 1. I am now user 50, but doesn't matter. I can now see trainer 1's data like so, just to spare time. You do please the same, yeah? You please go and also navigate to trainer 1's data. What we are going to show now is a tool called OMERO.parade, which is a data mining tool, and we will show how to go through the images which are stored in OMERO based on the qualities of the images, such as came from the results tables coming ultimately from our analysis in Fiji. Okay, so if we select the project called IDR 0021, then I already promised that the Fiji dataset, which we were working on before the break, is just like kind of best off from the full study, and the study is the IDR 0021 published images which are super resolution confocal super resolution microscopy of the centrioles, so subcellular structures. Okay, and we have run using the Fiji script, which we were plentifully demonstrating, the segmentation on all 414 of them. Okay, this resulted in an OMERO table. And the OMERO table is here as an attachment. Furthermore, we produced a CSV, a comma-separated value, things which you can open in OMERO Excel, as in Excel, of course, in Microsoft Excel, and just to show that you can do both. Okay, just it's a redundant thing, but it will show the power of the system. And now when I click on the I on the attachments tab on the summary from Fiji, I can study the OMERO table, which was produced in Fiji. Now let me you can do some querying of the table like so. So it just shows that where the count is greater than 400. Okay, so this is some parameter coming from Fiji. Okay, and I can filter inside the OMERO table. That's great, but OMERO.parade can do much better than that. Let me just allow a small aside. One other thing, one other advantage which the OMERO table gives you is that you can, in the web client, when you navigate to a single image inside that portfolio, you can click on the tables tab and you can see that the values which are pertaining for this image from that OMERO table are displayed under tables tab. So basically, the OMERO table has quite a few columns, and each column here is displayed as a row, and the values from the row which pertains to the image number 5 from the CDK for RAP dataset are displayed in this tab. Yeah, that's the image I'm selecting. So in this way, you can also add metadata to your images. Even if you would not use OMERO.parade for data mining, this can be quite handy. And we also ship a script which will do that for you using a UI. You don't have to bother with Fiji. Let's say you have your data as a CSV. And if you would like to turn your CSV into a OMERO table, you can do it using this script, which is under import scripts, and it's called populate metadata. And if you click on that, you can see, you can select a, let's say, data set. And on, if I would have been selected, if a full data set here would be selected, then it would pre-populate. Let's do it. I select, let's say, a data set called SVS, and I can populate metadata. You can see that the ID of this dataset is pre-populated in that script, and now the attachment is not there. Okay, so I don't have any CSV attachment attached, but it doesn't matter. I can browse and I can say upload the CSV, let's say this one, and it will do it for me, and then I will run the script which will create some tables, and then it will display them as values here. So we've done you can do that as well. Okay, if the CSV has certain qualities which you can find described in the OMERO guide. If you search in the OMERO guides for populate metadata, okay? So you go to OMERO guide, search for that, and you will find how to create an OMERO table in a more easy way than when using Fiji. Good. But back to what we wanted to show, and this is OMERO.parade. So we're having the table, or indeed having just a simple CSV. So OMERO.parade now swallows both. We can simply click on the super container, which is the project in this case, and select OMERO.parade in the central pane from the drop-down menu just to the right-hand side above the central pane. And if we do that, we can see if I close the data set on the left-hand side, no data sets are open, and thus the OMERO.parade does not show anything. It just works on the open data set. I can go open all, and it will open all the images in all 10 data sets, all 414 of them. I can add now filter. For example, I can filter them by regions of interest count. So how many regions of interest did Fiji draw on each of those images? I can fathom it out like that. I can say the regions of interest number on that image must be bigger than 20, but it must be smaller than 50. And here I go. I have the images here filtered out, which have image regions of interest numbers such as 35 or 48, which is definitely between 20 and 50. Okay, I can remove this filter, and I can go ahead and say I want to show a table view of those thumbnails in the center pane, and I can add table data into the table view. So let's say you can see here that I can add data from the CSV, but I can add data from the OMERO table as well. As indicated, the OMERO table has one row per each image, and so does the CSV. I can add the table total area, which is the area of the biggest region of interest in that image, as a column like so. And I can also add a table bounding box, which is the area of the bounding box, which encompasses the biggest region in the image. And then I will add simply table image, which is the ID of the image. Having these three columns like so, I can now check the checkbox, which will simply switch on the color coding on the rows, and I can do it for all three and sort the data according to the value in this column. And I can do it per data set, or I can do it for all. These images have simply no values in the CSV, and I can now.
Peter, sorry, can you show again how to add more filter? Christina missed that.
Yes, so I am adding filter. Okay, so here. So for example, I can filter for.
But you're in this as the middle. You're in the middle tab already. Is it? Or you just? Yeah, continue. Sorry.
So filter addition is here, okay? So I can do that still. I can still add here a filter, and I can go between 20. You see, so I'm filtering also, doesn't matter that I'm already inside the tab, and I can add another filter for smaller than 50 regions of interest, okay? And now I can, oh, okay, got it. Okay. Yeah, exactly. You have to always drop down the menu again and again. You can go by rating, okay? Rating 2, and this will filter them all out because none of them has any rating, yeah? Etc. etc. That's fine. I know that this might be slightly, the controls here are a little bit over the top. OMERO.parade is still kind of in its infancy, and this is not completely, how to say, matured in the usability sense. That I'm using another menu to add new columns into this view. Okay, so this is the lower menu, which is saying add table data. But I have added already my 3 columns, and you can see the sorting capabilities of here, and I can already see some patterns here on this heat map coded rows for those 3 parameters. Yeah, so if I, let's say, sort according to total area, I can see that these ones have the biggest total area, etc., etc. And very interestingly, I have here a graph icon on the top right. And if I click on that small graph icon, I can go and see a graph. Each point in this graph represents an image. And if I swap the axis here, let's say like this, like so, I have table total area on the y-axis, and on the x-axis I have table bounding box. And because I know what the parameter mean, then I am quite unnerved by the two outliers here, which have such big bounding box compared to their area. So I would like to know if my automatic analysis in Fiji really produce sensible regions of interest for those two images, or if indeed they are invalid. For that, I would open those two images in OMERO.iviewer, like so. Here is an open with menu, or yeah, so I can click on that. And this is another power of OMERO.iviewer. It can open any images, any collection of images which you select in the tree in the left-hand side, or indeed using OMERO.parade as I just did. So it doesn't have to be from the same data set. And I can inspect the regions of interest here. And because I was telling you that in those values, it's always the biggest region of interest on the image, which is gonna contribute to the to the statistics and evaluation, I can see immediately that this biggest region in this image is invalid. It does not encompass the two centrioles in the image like so. This would be one centriole, this would be another centriole. Instead, it's a huge region of interest of the shape of a big sausage, and has two unwished for whiskers here, and it encompasses both of the centrioles. So this didn't go well for this image for Fiji, and I can discard this ROI from my evaluation. So you can see the power of OMERO.parade as a quality assurance tool. Good. Now, let me just show you another tool on this note, which we have in our portfolio, and this is called OMERO.figure. The OMERO.figure is probably our most popular tool in OMERO. It allows you to create publication figures for presenting in a scientific journal, but even more modestly, if you just want to show data quickly to your boss or on a lab meeting, then indeed you can do figure creation in this very quick manner, which we will just demonstrate as we go. Before we do that, though, because we have a little bit time of spare, let me show you one more power of the OMERO.parade, which will bind nicely to our previous workflow with Cell Profiler. So you remember that we were working with Cell Profiler on this plate, and we were analyzing basically 5 wells out of this 96 well plate. Which is great, but we would like to analyze it all. Why didn't we do that? Well, because of time reasons, obviously, but we did it already for you previously. So we have the OMERO table here for that plate. This was done by Cell Profiler, again, viewing the OMERO table on the plate called IDR00, no, pardon me, plate called plate 01 underscore 13 underscore previously analyzed, as I'm highlighting here on the bottom left. Okay, now I can drag it. Very good. So you can see the name plate 1 underscore 013 previously analyzed in the data of trainer 1. That's what I'm playing with now. So I zoom it out so that I can see all the wells. In the plate, I already showed you the attached table, which comes from previous analysis. And I can now switch on OMERO.parade again and say, I want to add filter from the table obviously being this one, this thing. So I can filter in the table. Now in the table, in the OMERO table, there can be strings, meaning non-numerical values, like text values, but there can also be numerical values such as cell count, which is probably the most human understandable parameter. It's simply the number of the cells which were detected by cell profiler in this particular well. Okay, so if I now start dragging the slider, you can see that the wells which have now a lower cell count than the 35, which is highlighted here, okay, are vanishing, whereas the ones which fulfill the criteria are still being shown. Okay, I can of course, again, as you asked, I can of course add the cell count again, as we did with the Royce in the previous example, and it will be bigger than 35, but smaller than 40, then 45, 46, smaller than 46, so bigger than 33 and smaller than 46. Okay, so that's where I am in between. And if I, let's say, remove this filter, then I can go and show only the ones which have exactly 33 cells in them. And you can see here in the tables, if I select such well, which I filtered for, if you click on the tables, by selecting this well, you can see that there is on the bottom a cell count, and it says indeed 33. Unsurprisingly, because both these this content of this harmonica as well as the OMERO.parade are picking data from the same place, and the place is the attached OMERO table. Very good. So much for the OMERO.parade. And if I go back to the thumbnails view and let's say select some images from again this portfolio, just to demonstrate, I can select an image which has, let's say, 2 channels here, and another image which is also 2 channels from 2 different data sets. It's fine. Okay. And now I can go and open with OMERO.figure. So coming back to what I highlighted some 3 minutes ago, OMERO.figure is this great tool for creation of quick publication figures. And if I do so, selecting those 2 images from 2 different data sets, open with OMERO.figure. And then I have a new tab opening in my Firefox, and I have those 2 images in the environment where I can sort them out and create an OMERO figure and a publication figure from them. So what OMERO figure actually is? Well, it's a plugin for OMERO Web, obviously. And as I'm doing that, you can do that with me. And it fetches the data on the fly from OMERO. So it remembers which images are contained in those 2 panels. This is not somehow disjointed. It's completely connected to OMERO, and in any time it can come back to OMERO and ask for metadata pertaining to those 2 images. So I just made the images smaller, and now I will do copy and paste and paste. This is a usual trick. I showed you a taster of this already in the OMERO.iviewer, where we were doing the split view, okay? And now I will make it a little bit bigger. And now I'll do from the first column, I will do a green channel. From the second column, I'll do a red channel. And for me, it's here almost invisible. So I can change the rendering settings even in OMERO figure to adjust them to see much more in those images and in the red channel as well. Okay, very good. And this will be my merge. Excellent. Okay. And now I can see that the images have a very small object inside them. So I can select I can select them all and I can zoom in. You see the object jumped in. So this is the centriole, obviously, and I need some adjustment. I need a little bit different adjustment from on the top and on the left. So I can just select the bottom and I will adjust it like so. And then I select the top row and I will adjust the top row like this. Very good. I still think I need some adjustment in the green channel here. Okay. And in the red channel. Okay, very good. And then I can go and add some labels on the top of those images to signify where they are coming from and some such. This would be done by selecting the top row and then selecting the channels in the labels tab at the bottom. I will select the higher, a bigger font for them. 18, let's say. I don't have to worry about the color. They will pop up on the top here because that's what I want. If I select it like that, here you go. So the channel names are CDK something something and NED1, and this is the merge. Okay, so that's done. I had no idea what the channel names are, but OMERO.figure sorted it out for me, and I can now add to the left, I can add the dataset name. So there's some metadata encoded in the dataset name. In this case, these are the names of the proteins which were stained for the images in this particular dataset. Okay, and I will pop it in the left vertical and again 18, and it will appear here. I will say add. Indeed, these are two different proteins because they are from two different datasets. Great. Having done that, I will nudge with my keys on the keyboard the thing to the left, and I would like to create an insert here. So first of all, it's a good idea always to add some labels. So I know if I go for nanometers, something like 500, and then I say show labels. I wanted to say scale bar, of course, that's what I did here. So the scale bar is added as easy as that. Again, the metadata, the calibration of this image was asked by OMERO.figure from OMERO and was instantly delivered for that image, and OMERO.figure stamped the scale bar on the image. Now I will copy that image and paste it with the intention to do a crop. I can do then in the preview on the copied image, I can simply zoom in. Yeah, and it looks like a crop. Okay. Now I can retrieve regions of interest, let's say on the original image. Now, first of all, how to finish off the crop workflow. If I copy the region so that I have an insert here, of the cropped area in the original image, I can copy it from the crop and then click on the original image, go to labels and say paste. Did you see how I did it? So I have now the insert of the cropped region on the original image, and now I can let's say add some regions of interest. I will do that on this image. I can fetch the regions of interest from OMERO. Ultimately, these regions of interest are coming from Fiji. Okay, so this one is a good one. I want this. Yes, fine. I say okay, and the region of interest is there. It's a little bit too dim, 3pt, and I will make it, yeah, magenta, why not? Okay, so you can see this region of interest has been added here. Magenta is too funky. Maybe let's go for yellow. Oh. White was in the end the best, and I will make it a little bit thicker, 5. Okay, great. So this is a little bit over the top, but it shows the point. So I just added the region of interest, which is coming from the Fiji segmentation. You can see that it's fairly sensible on this one, and I'm kind of happy with this slot. But you know that in the scientific publication, it's very often that one figure contains a mixture of data from very different imaging or even other modalities. So let's just try to add images from some other imaging modalities from a different data set in OMERO into this figure. How do I do this? I go back to OMERO web client, and I can now find us these conventional microscopy data which we were playing with at the beginning of the workshop, and these are in the siRNAi HeLa dataset. And if I now let's say filter by rating, as I was showing to you 2 hours ago, I can see that some images were filtered out like this, and if I select some of them, then I can say, okay, these are the best ones, and I will maybe go and open them with OMERO.figure, but this would open a new OMERO.figure for me. Instead, I want to add them to the existing OMERO.figure. How do I do that? So I click on the chain icon on the top right, and a link pops up. I will copy that link, and then I go to the tab where my OMERO.figure is living, and I will select the Add Images button. This will pop up a dialog. I paste my link to those additional 3 images from OMERO to OMERO.figure, and I will again sort the pane here. The 3 images are selected now, and I will snap them to grid, make them a little bit smaller, and go through the same routine such as I did with the previous batch. This means I copy and paste them maybe 4 times. Then I select this for this being a blue channel, this being a green channel, this being a first red channel, and this being a merge. That's fine. I will adjust the first red. That's better. And I can now again add some labels. So I'm adding the labels from this time from channels again on the top. First of all, yeah, DAPI, FITSI, GFP, INSEMP, and the merge. And I can add some on the left vertical. This time I would choose, let's say, the key value pairs. Okay, so if I go for key value pairs on left vertical, I add, and it says animal. That's less interesting. But what about yeah, temperature? Okay, so I need to select it because the label is a little bit. Okay, so you can see temperature is different for all 3 of them. That's great. And still, I think I'm quite happy with the layout. I can add also another label according to tags. I think if this would be left vertical, I add, and you can see these are the mitotic phases, but the temperature is different for each of them. So anaphase has 37, prometaphase 40, and metaphase also 40. Okay, so you can add really a lot of metadata from OMERO, and OMERO.figure always goes to OMERO, asks what the metadata are, such as tags or key value pairs, and pops them onto your image as labels. Now I can go and adjust the Z section of this image if this is a multi-Z section image, such as this one. And I can go through the Z sections even here, or indeed I can make a projection. So basically, I think that you can start to understand that this is basically solving the horrific workflow which a scientist typically does from a software of interest, such as SciZen software, where you have to export the image let's say, as JPEG from the original image. You have to select first the correct plane, then export this plane, put it into Adobe Illustrator. By the way, nothing against those two softwares. Yeah, Adobe Illustrator or the Zen are great softwares, but the problem is once you disjoint the workflow chain between those two, as you do when you export stuff plane by plane and then put them into your figure, and then later find that you can't work with that particular Z plane, you have to go back to the Zen software, export another Z plane, and this will lose you tons of time, and of course a lot of working effort. Whereas here, whilst you are still in a very late stages of the preparation of your figure, you can very easily double back on yourself and correct all your mistakes by simply sliding those sliders. Good. So having done that, I think I will just go back to the labels, and you can see that even post hoc, if I select those three images, I can see that the labels are simply too big. So I can go and make them smaller. Let's say 12. Yeah, and this one is also 12. And yeah, so you can see I could make those labels smaller even much later. I'm happy now. I will add the scale bar as is a good practice. 10 micrometers should be fine. Scale bar is there, excellent. And now I can go and save the figure. I will make a nice name such as I2K dash Janelia, and I will see the name of the figure popping up here. Now the URL here in my browser has changed when I did the save action. And this is quite significant because I can grab this URL, copy it, and send an email to my fellow scientist, which would like to work on that figure as well. If they receive that email and they have this link in that email, they can simply click on that link in the email, and this will open a new tab in their browser. And if they are logged into OMERO, then they will be straight seeing this figure of mine. If they are not logged into OMERO, they will see a login screen. After they log in, then they will be immediately re-navigated to this link, which obviously contains this figure of mine, and they will be able to see this figure, make comments, make their own copies of that figure, and continue working on that, and some such. Furthermore, I can export the figure to send it to, let's say, scientific journal by clicking the export PDF button. So the figure is being exported right now. And on the server, a PDF is created, and I can now download this PDF. And on my local machine, I can open it with Preview. This is a program for viewing images and PDFs, and it's already happening. So this is already not on the server. It's here on my local Mac in my flat. And I can see that I have obviously the figure with the two panels. And this is not surprising, but why do I have a 2-page PDF from 1-page figure? Well, this is because I have a kind of a metadata page added to this figure page. First of all, the first link is pointing to the OMERO figure itself. So that's the link I was suggesting to send via email to my fellow scientist. So I can click on it in this PDF, and I am jumping directly, because I am logged into OMERO, I'm jumping directly to that figure in my browser. Secondly, typically, when you go and send something into a scientific journal, the process can be quite long, and then they come back to you and say that you need to change panel B on figure 7, and you don't know anymore what are the original raw data underlying the panel B in figure 7. If you go to OMERO figure, you click on this link, you can immediately see exactly what are the images which are used in that figure. So it will bring you an open and you tap in your browser, and the OMERO will find it for you. Very good. Furthermore, if you go to your OMERO figure and see, that's not where I was, but doesn't matter. See the top left, there is a file menu. If you click on that, you can open from that file menu, let's say, and browse the figures of your colleagues. If you have the right to see the figures of your colleagues, I mean, I am Irene Joliot-Curie, obviously, and I have just one figure. That's the one which I just saved. But I can go to the portfolios of my colleagues with their figures and go to trainer 2. I know that my colleague trainer 2 has one figure, but it's really worth it. And I open it. And this more or less showcases what everything can be done with OMERO figure. I can create a multi-page figure. I can do a legend here on the bottom. I can draw new regions of interest, such as these arrows here were drawn post hoc in figure. This would be on top of those regions of interest, which I showed to you how to get from OMERO, which were ultimately coming from the Fiji image analysis. So I can draw such arrows. Here is an insert on a very large image. So this is this 100,000 by 50,000 pixel image. So OMERO figure can handle that as well. If I have my Western blots as PNGs and import them to OMERO, nothing stops me to put them into my OMERO figure. As well as, let me highlight the feature of this flexibility of OMERO figure and the changes which can be done on the fly, even post hoc, on things like time lapses here. So you can see that I obviously have 2 time lapses with a sampling, let's say every 40 minutes. And I now realize that this time point, I don't want 42 minutes. I want some later time point. I simply select this, or I can indeed select both of those images. And then I can slide the slider to the right, which will go to the later times. And did you see it changed the labels from 42 to 57 minutes, because now I'm simply highlighting another time point to which I scrolled in the preview panel. And because all the labels are, so to say, live, they are connected via OMERO figure to OMERO, and OMERO knows about what is the delta t between the time point planes, as well as how many time point planes did I pass through when scrolling, etc. OMERO figure can ask OMERO on the fly and change the values as appropriate, both the image displayed in the viewports as well as the label value which corresponds. Okay, I hope that you understand now the power of OMERO figure. Maybe last word on it. If I have the PDF like like the one which I have here locally, say this one, I can still go and open it and post hoc adjust things like, let's say, fonts of labels in software such as Adobe Illustrator. So as I said, nothing against Adobe Illustrator. I can still open the PDF and these things will be vectors. And I can, let's say, choose the font Calibri instead of Times New Roman, which is not something which OMERO figure will do for me. Nevertheless, of course, once being in Adobe Illustrator, I lose this nice connection between OMERO figure and OMERO. But nevertheless, this would be a nice follow-up on the workflow I showed you. Are there any questions, ladies and gentlemen? We are kind of at the end of the 4-hour workshop. We will definitely go back to Sylvia's question, and you are all welcome to stay and ask more questions or play further. But are there any questions for the parts which we were showing?
You can, the account will still be active for for a few days, so you can use at any time. So we're not going to shut it down. So you can use any of the plugin, the notebook against the account that using the credential you were given at your own time.
Yeah. Okay. Thank you very much for your reactions. I can now see. You know, it's quite common that people like OMERO.figure. It's really likable, and for the.
I just put as well a link to if people are interested and do not want to install the server, because obviously everything we've shown you, you need to have a server installed. And if you don't have your a server installed and want to play to see if the tool will meet your need, just you can request a demo account that's free of charge, and then you sign up for a demo account. You will be able to import your own data there. And I will not, if you start to use it in anger, you probably need your server, because that's not some server we guarantee. We know we need to update it from time to time, and I will not do my research in that environment, but it's a good way of exploring yourself. And if you want to present it to others, that's also without too much effort. You just request a demo account. And when you have a demo account, you will not see other people's data. So that you are in what Peter has shown today is you are in an environment where we can see each other data to show the power of collaborative work. But when you create a demo account, you are not in this type of environment. So only you will see your data. So you don't be worried about putting your own data, even if it's at early stage of your work.
Okay. So yeah. So thanks to everybody. I think if no other questions, we will swap to